Hi everyone, welcome to the final day of the week of our data science journey by Simplilearn. On day 6, we learned about deep learning for data science. Today, that is on day 7, we are going to focus on the top data science interview questions that will help you crack a data science interview. Now that you have already learned all the important data science skills in the past 6 days, now it is time for you to put your knowledge to the test and check whether you are able to answer critical interview questions on machine learning, deep learning and data science concepts. So let's begin.
This video will probably help you when you're attending interviews for machine learning positions, and the attempt here is to probably consolidate 30 most commonly asked questions and to help you in answering these questions. We tried our best to give you the best possible answers, but of course what is more important here is, rather than the theoretical knowledge, you need to kind of add to the answers or supplement your answers with your own experience. So the responses that we put here are a bit more generic in nature, so that if there are some concepts that you are not clear, this video will help you in kind of getting those concepts cleared up as well. But what is more important is that you need to supplement these responses with your own practical experience. Okay, so with that, let's get started. So one of the first questions that you may face is, what are the different types of machine learning? Now, what is the best way to respond to this? There are 3 types of machine learning. If you read any material, you will always be told there are 3 types of machine learning. But what is important is you would probably be better off emphasizing that there are actually 2 main types of machine learning, which is supervised and unsupervised. And then there is a third type, which is reinforcement learning. So supervised learning is where you have some historical data and then you feed that data to your model to learn. Now, you need to be aware of a keyword that they will be looking for, which is labeled data. Right? So if you just say past data or historical data, the impact may not be so much. You need to emphasize on labeled data. So what is labeled data? Basically, let's say if you're trying to train your model for classification, you need to be aware of, for your existing data, which class each of the observations belong to, right? So that is what is labeling. So it is nothing but a fancy name, you must be already aware, but just make it a point to throw in that keyword labeled, so that will have the right impact. Okay, so that is what is supervised learning, when you have existing labeled data which you then use to train your model. That is known as supervised learning. And unsupervised learning is when you don't have this labeled data. So you have data, it is not labeled. So the system has to figure out a way to do some analysis on this. Okay, so that is unsupervised learning. And you can then add a few things like what are the ways of performing supervised learning and unsupervised learning, or what are some of the techniques. So supervised learning, we perform, or we do regression and classification, and unsupervised learning we do clustering. Okay? And clustering can be of different types. Similarly, regression can be of different types, but you don't have to probably elaborate so much. If they are asking for just the different types, you can just mention these and just at a very high level. But if they want you to elaborate, give examples, then of course I think there is a different question for that. We will see that later. Then the third, so we have supervised, then we have unsupervised, and then reinforcement. You need to provide a little bit of information around that as well, because it is sometimes a little difficult to come up with a good definition for reinforcement learning. So you may have to a little bit elaborate on how reinforcement learning works. Right? So reinforcement learning works in such a way that it basically has 2 parts to it. One is the agent and the environment. And the agent basically is working inside of this environment, and it is given a target that it has to achieve. And every time it is moving in the direction of the target, so the agent basically has to take some action. And every time it takes an action which is moving the agent towards the target, right, towards a goal. A target is nothing but a goal. Okay, then it is rewarded, and every time it is going in a direction where it is away from the goal, then it is punished. So that is the way you can a little bit explain. And this is used primarily, or very, very impactful for teaching the system to learn games and so on. Examples of this are basically used in AlphaGo. You can throw that as an example where AlphaGo used reinforcement learning to actually learn to play the game of Go, and finally it defeated the Go world champion. Right? This much of information that would be good enough. Okay. Then there could be a question on overfitting. So the question could be, what is overfitting and how can you avoid it? So what is overfitting? So let's first try to understand the concept, because sometimes overfitting may be a little difficult to understand. Overfitting is a situation where the model has kind of memorized the data. So this is an equivalent of memorizing the data. So we can draw an analogy so that it becomes easy to explain this. Now let's say you're teaching a child about recognizing some fruits or something like that. Okay? And you're teaching this child about recognizing, let's say, 3 fruits: apples, oranges, and pineapples. Okay, so this is a small child, and for the first time you're teaching the child to recognize fruits. Then, so what will happen? So this is very much like that is your training data set. So what you will do is you will take a basket of fruits which consists of apples, oranges, and pineapples. Okay, and you take this basket to this child, and there may be, let's say, hundreds of these fruits. So you take this basket to this child and keep showing each of this fruit, and then first time obviously the child will not know what it is. So you show an apple and you say, hey, this is apple. Then you show maybe an orange and say this is orange, and so on and so forth. And then again you keep repeating that, right? So till that basket is over. This is basically how training works. In machine learning also, that's how training works. So till the basket is completed, maybe 100 fruits, you keep showing this child. And then in the process, what has happened, the child has pretty much memorized these. So even before you finish that basket, right, by the time you are halfway through, the child has learnt about recognizing the apple, orange, and pineapple. Now what will happen after halfway through? Initially you remember it made mistakes in recognizing, but halfway through now it has learned. So every time you show a fruit, it will exactly 100% accurately, it will identify. It will say, the child will say this is an apple, this is an orange, and if you show a pineapple, it will say this is a pineapple. Right? So that means it has kind of memorized this data. Now let's say you bring another basket of fruits, and it will have a mix of maybe apples, which were already there in the previous set, but it will also have, in addition to apple, it will probably have a banana or maybe another fruit like a jackfruit. Right? So this is an equivalent of your test data set, which the child has not seen before. Some parts of it probably has seen, like the apples it has seen, but this banana and jackfruit it has not seen. So then what will happen? In the first round, which is an equivalent of your training data set, towards the end it has 100% it was telling you what the fruits are. Right? Apple was accurately recognized, orange was accurately recognized, and pineapples were accurately recognized. Right? So that is like 100% accuracy. But now when you get a fresh set which were not a part of the original one, what will happen? All the apples maybe it will be able to recognize correctly, but all the others like the jackfruit or the banana will not be recognized by the child. Right? So this is an analogy, this is an equivalent of overfitting. So what has happened during the training process, it is able to recognize or reach 100% accuracy, maybe very high accuracy. Okay, and we call that as very low loss. Right? So that is the technical term. So the loss is pretty much 0 and accuracy is pretty much 100%. Whereas when you use testing, there will be a huge error, which means the loss will be pretty high and therefore the accuracy will be also low. Okay, this is known as overfitting. This is basically a process where training is done. Training process it goes very well, almost reaching 100% accuracy, but while testing, it really drops down. Now, how can you avoid it? So that is the extension of this question. There are multiple ways of avoiding overfitting. There are techniques like what you call regularization. That is the most common technique that is used for avoiding overfitting. And within regularization, there can be a few other subtypes like dropout in case of neural networks and a few other examples. But I think if you give example or if you give regularization as the technique, probably that should be sufficient. So there will be some questions where the interviewer will try to test your fundamentals and your knowledge and depth of knowledge and so on and so forth. And then there will be some questions which are more like trick questions that will be more to stump you. Okay, then the next question is around the methodology. So when we are performing machine learning training, we split the data into training and test, right? So this question is around that. So the question is, what is training set and test set in machine learning model, and how is the split done? So the question can be like that. So in machine learning, when we are trying to train the model, so we have a 3-step process. We train the model, and then we test the model, and then once we are satisfied with the test, only then we deploy the model. So what happens in the train and test is that you remember the labeled data. So let's say you have 1,000 records with labeling information. Now, one way of doing it is you use all the 1,000 records for training, and then maybe, right, which means that you have exposed all these 1,000 records during the training process, and then you take a small set of the same data and then you say, okay, I will test it with this. Okay, and then you probably, what will happen, you may get some good results. Right? But there is a flaw there. What is the flaw? This is very similar to human beings. It is like you are showing this model the entire data as a part of training. Okay, so obviously it has become familiar with the entire data. So when you're taking a part of that again and you're saying that I want to test it, obviously you will get good results. So that is not a very accurate way of testing. So that is the reason what we do is we have the label data of this 1,000 records or whatever. We set aside, before starting the training process, we set aside a portion of that data and we call that test set, and the remaining we call as training set, and we use only this for training our model. Now, the training process, remember, is not just about passing one round of this data set. So let's say now your training set has 800 records. It is not just one time you pass this 800 records. What you normally do is you actually, as a part of the training, you may pass this data through the model multiple times. So this 1,000 records may go through the model maybe 10, 15, 20 times till the training is perfect, till the accuracy is high, till the errors are minimized. Okay, now, so which is fine, which means that that is what is known as the model has seen your data and gets familiar with your data. And now when you bring your test data, what will happen is this is like some new data, because that is where the real test is. Now you have trained the model and now you are testing the model with some data which is kind of new. That is like a situation, like a realistic situation, because when the model is deployed, that is what will happen. It will receive some new data, not the data that it has already seen, right? So this is a realistic test. So you put some new data. So this data which you have set aside is for the model, it is new. And if it is able to accurately predict the values, that means your training has worked. Okay, the model got trained properly. But let's say while you're testing this with this test data, you're getting a lot of errors. That means you need to probably either change your model or retrain with more data and things like that. Now, coming back to the question of how do you split this, what should be the ratio? There is no fixed number. Again, this is like individual preferences. Some people split it into 50-50, 50% test and 50% training. Some people prefer to have a larger amount for training and a smaller amount for test. So they can go by either 60-40 or 70-30, or some people even go with some odd numbers like 65-35 or 63.33 and 33, which is like 1/3 and 2/3. So there is no fixed rule that it has to be something, the ratio has to be this. You can go by your individual preferences. All right, then you may have questions around data handling, data manipulation, or what do you call data management or preparation. So these are all some questions around that area. There is again no one answer, one single good answer to this. It really varies from situation to situation, and depending on what exactly is the problem, what kind of data it is, how critical it is, what kind of data is missing, and what is the type of corruption. So there are a whole lot of things. This is a very generic generic question, and therefore you need to be a little careful about responding to this as well. So probably have to illustrate this again. If you have experience in doing this kind of work in handling data, you can illustrate with examples saying that I was on one project where I received this kind of data. These were the columns where data was not filled, or these were this many rows where the data was missing. That would be, in fact, a perfect way to respond to this question. But if you don't have that, obviously, you have to provide some good answer. I think it really depends on what exactly the situation is. And there are multiple ways of handling the missing data or corrupt data. Now, let's take a few examples. Now, let's say you have data where some values in some of the columns are missing, and you have pretty much half of your data having these missing values in terms of number of rows. Okay, that could be one situation. Another situation could be that you have records or data missing, but when you do some initial calculation, how many records are corrupt, or how many rows or observations, as we call it, has this missing data. Let's assume it is very minimal, like 10%. Okay. Now, between these two cases, how do we? So let's assume that this is not a mission critical situation, and in order to fix this 10% of the data, the effort that is required is much higher, and obviously effort means also time and money, right? So it is not so mission critical, and it is okay to, let's say, get rid of these records. So obviously one of the easiest ways of handling the data part or missing data is remove those records or remove those observations from your analysis. So that is the easiest way to do. But then the downside is, as I said, as in the first case, if let's say 50% of your data is like that, because some column or the other is missing. So it is not like in every place, in every row, the same column is missing, but you have in maybe 10% of the records, column 1 is missing, and another 10% column 2 is missing, another 10% column 3 is missing, and so on and so forth. So it adds up to maybe half of your data set. So you cannot completely remove half of your data set, then the whole purpose is lost. Okay, so then how do you handle? Then you need to come up with ways of filling up this data with some meaningful value, right? That is one way of handling. So when we say meaningful value, what is that meaningful value? Let's say for a particular column, you might want to take a mean value for that column and fill wherever the data is missing, fill up with that mean value, so that when you're doing the calculations, your analysis is not completely way off. So you have values which are not missing, first of all, so your system will work. Number two, these values are not so completely out of whack that your whole analysis goes for a toss. Right? There may be situations where if the missing values, instead of putting mean, maybe a good idea to fill it up with the minimum value or with a 0. So, or with a maximum value. Again, as I said, there are so many possibilities. So there is no like one correct answer for this. You need to basically talk around this and illustrate with your experience. As I said, that would be the best. Otherwise, this is how you need to handle this question. Okay, so then the next question can be, how can you choose a classifier based on a training set data size? So again, this is one of those questions where you probably do not have like a one-size-fits-all answer. First of all, you may not, let's say, decide your classifier based on the training set size. Maybe not the best way to decide the type of the classifier. And even if you have to, there are probably some thumb rules which we can use. But then again, every time, so in my opinion, the best way to respond to this question is you need to try out few classifiers irrespective of the size of the data, and you need to then decide on your particular situation which of these classifiers are the right ones. This is a very generic issue, so you will never be able to, just by if somebody defines a problem to you, and somebody, even if they show the data to you or tell you what is the data or even the size of the data, I don't think there is a way to really say that yes, this is the classifier that will work here. No, that's not the right way. So you need to still, test it out, get the data, try out a couple of classifiers, and then only you will be in a position to decide which classifier to use. You try out multiple classifiers, see which one gives the best accuracy, and only then you can decide. Then you can have a question around confusion matrix. So the question can be, explain confusion matrix. matrix, right? So confusion matrix, I think the best way to explain it is by taking an example and drawing like a small diagram. Otherwise it can really become tricky. So my suggestion is to take a piece of pen and paper and explain it by drawing a small matrix. And confusion matrix is about to find out, this is used especially in classification learning process, and when you get the results, when our model predicts the results, you compare it with the actual value and try to find out what is the accuracy. Okay, so in this case, let's say this is an example of a confusion matrix, and it is a binary matrix. So you have the actual values, which is the labeled data, right? And which is, so you have how many yes and how many no. So you have that information, and you have the predicted values, how many yes and how many no, right? So the total actual values, the total yes is 12 plus 1, 13, and they are shown here. And the actual value no's are 9 plus 3, 12. Okay, so that is what this information here is. So this is about the actual and this is about the predicted. Similarly, the predicted values, there are yes are 12 plus 3, 15 yeses, and no are 1 plus 9, 10 no's. Okay, so this is the way to look at this confusion matrix. Okay, and out of this, what is the meaning conveyed here? So there are 2 or 3 things that needs to be explained outright. The first thing is, for a model to be accurate, the values across the diagonal should be high, like in this case, right? That is one. Number 2, the total sum of these values is total sum in this matrix, the numbers is equal to the size of the test data set, and the diagonal values indicate the accuracy. So by looking at it, you can probably have an idea about, is this an accurate model? Is the model being accurate? If they're all spread out equally in all these 4 boxes, that means probably the accuracy is not very good. Okay, now how do you calculate the accuracy itself, right? How do you calculate the accuracy itself? So it is a very simple mathematical calculation. You take sum of the diagonals, right? So in this case it is 9 plus 12, 21, and divide it by the total. So in this case, what will it be? Let me take a pen. So your diagonal values is equal to, if I say D is equal to 12 plus 9, so that is 21, right? And the total data set is equal to, right, we just calculated, it is 25. So what is your accuracy? It is 21 by, so your accuracy is equal to 21 by 25, and this turns out to be about 85%. Right? So this is 85%. So that is our accuracy. Okay. So this is the way you need to explain, draw a diagram, give an example, and maybe it may be a good idea to be prepared with an example so that it becomes easy for you. You don't have to calculate those numbers on the fly, right? So a couple of hints are that you take some numbers which add up to 100. That is always a good idea, so you don't have to really do this complex calculations. So the total value will be 100, and then diagonal values you divide. Once you find the diagonal values, that is equal to your percentage. Okay. All right. So the next question can be a related question about false positive and false negative. So what is false positive and what is false negative? Now, once again, the best way to explain this is using a piece of paper and pen. Otherwise, it will be pretty difficult to explain this. So we use the same example of the confusion matrix, and we can explain that. So a confusion matrix looks somewhat like this, and when we just take it looks somewhat like this, and we continue with the previous example where this is the actual value, this is the predicted value, and in the actual value we have 12 plus 1, 13 yeses, and 3 plus 9, 12 no's, and the predicted values, there are 12 plus 3, 15 yeses, and 1 plus 9, 10 no's. Okay. Now, in this particular case, which is the false positive, what is a false positive? First of all, the second word, which is positive, okay, is referring to the predicted value. So that means the system has predicted it as a positive, but the real value, so this is what the false comes from, but the real value is not positive. Okay, that is the way you should understand this term, false positive or even false negative. So false positive, so positive is what your system has predicted. So where is that system predicted? This is the one. Positive is what? Yes. So you basically consider this row. Okay. Now if you consider this row, so this is all positive values. This entire row is positive values. Okay. Now the false positive is the one where the actual value is negative. Predicted value is positive, but the actual value is negative. So this is a false positive, right? And here is a true positive. So the predicted value is positive and the actual value is also positive. Okay, I hope this is making sense. Now let's take a look at what is false negative. False negative. So negative is the second term. That means that is the predicted value that we need to look for. So which are the predicted negative values? This row corresponds to predicted negative values. All right. So this row corresponds to predicted negative values. And what they are asking for? False. So this is the row for predicted negative values and the actual value is this one, right? This is predicted negative and the actual value is also negative. Therefore, this is a true negative. So the false negative is this one. Predicted is negative, but actual is positive. Right? So this is the false negative. So this is the way to explain and this is the way to look at false positive and false negative. Same way, there can be true positive and true negative as well. So again, positive, the second term you will need to use to identify the predicted row, right? So if we say true positive, we need to take for the predicted part. So predicted positive is here. Okay, and then the first term is for the actual. So true positive. So true in case of actual is yes, right? So true positive is this one. Okay, and then in case of actual, the negative. Now we are talking about, let's say, true negative. True negative. Negative is this one and the true comes from here. So this is true negative, right? 9 is true negative. The actual value is also negative and the predicted value is also negative. Okay, so that is the way you need to explain the terms false positive, false negative, and true positive, true negative. Then you might have a question like, what are the steps involved in the machine learning process, or what are the 3 steps in the process of developing a machine learning model, right? So it is around the methodology that is applied. So basically, the way you can probably answer in your own words, but the way the model development of the machine learning model happens is like this. So first of all, you try to understand the problem and try to figure out whether it is a classification problem or a regression problem. Based on that, you select a few algorithms and then you start the process of training these models. Okay, so you can either do that, or you can, after due diligence, you can probably decide that there is one particular algorithm which is most suitable. Usually it happens through trial and error process, but at some point you will decide that, okay, this is the model we are going to use. Okay, so in that case, we have the model, algorithm and the model decided, and then you need to do the process of training the model and testing the model. And this is where, if it is supervised learning, you split your data, the labeled data, into training data set and test data set. And you use the training data set to train your model. And then you use the test data set to check the accuracy, whether it is working fine or not. So you test the model before you actually put it into production, right? So once you test the model, you're satisfied it's working fine, then you go to the next level, which is putting it for production. And then in production, obviously new data will come and the inference happens. So the model is readily available, and only thing that happens is new data comes and the model predicts the values, whether it is regression or classification. Now, so this can be an iterative process. So it is not a straightforward process where you do the training, do the testing, and then you move it to production. No. So during the training and test process, there may be a situation where, because of either overfitting or things like that, the test doesn't go through, which means that you need to put that back into the training process. So that can be an iterative process. Not only that, even if the training and test goes through properly and you deploy the model in production, there can be a situation that the data that actually comes, the real data that comes, with that this model is failing. So in which case you may have to once again go back to the drawing board. Or initially it will be working fine, but over a period of time, maybe due to the change in the nature of the data, once again the accuracy will deteriorate. So that is again a recursive process. So once in a while, you need to keep checking whether the model is working fine or not. And if required, you need to tweak it and modify it and so on and so forth. So net, this is a continuous process of tweaking the model and testing it and making sure it is up to date. Then you might have question around deep learning. So because deep learning is now associated with AI, artificial intelligence, and so on. So it can be as simple as what is deep learning? So I think the best way to respond to this could be deep learning is a part of machine learning. And then obviously the question would be, then what is the difference, right? So deep learning, you need to mention there are two key parts that interviewer will be looking for when you are defining deep learning. So first is, of course, deep learning is a subset of machine learning. So machine learning is still the bigger, let's say, scope, and deep learning is one part of it. So then what exactly is the difference? Deep learning is primarily when we are implementing these our algorithms, or when we are using neural networks for doing our training and classification and regression and all that, right? So when we use neural network, then it is considered as deep learning. And the term deep comes from the fact that you can have several layers of neural networks, and these are called deep neural networks, and therefore the term deep, deep learning. The other difference between machine learning and deep learning, which the interviewer may be wanting to hear, is that in case of machine learning, the feature engineering is done manually. What do we mean by feature engineering? Basically, when we are trying to train our model, we have our training data, right? So we have our training labeled data, and this data has several, let's say if it is a regular table, it has several columns. Now each of these columns actually has information about a feature, right? So if we are trying to predict height, weight, and so on and so forth, so these are all features of human beings. Let's say we have census data and we have all this. So those are the features. Now there may be probably 50 or 100, in some cases there may be 100 such features. Now all of them do not contribute to our model, right? So we as a data scientist, we have to decide whether we should take all of them, all the features, or we should throw away some of them. Because again, if we take all of them, number one, of course, your accuracy will probably get affected, but also there is a computational part. So if you have so many features and then you have so much data, it becomes very tricky. So in case of machine learning, we manually take care of identifying the features that do not contribute to the learning process, and thereby we eliminate those features and so on, right? So this is known as feature engineering, and in machine learning we do that manually. Whereas in deep learning, where we use neural networks, the model will automatically determine which features to use and which to not use, and therefore feature engineering is also done automatically. So this is an explanation. These are two key things probably will add value to your response. All right. So the next question is, what is the difference between, or what are the differences between machine learning and deep learning? So here, this is a quick comparison table between machine learning and deep learning. And in machine learning enables machines to take decisions on their own based on past data. So here we are talking primarily of supervised learning. And it needs only a small amount of data for training, and then works well on low-end systems, so you don't need large machines. And most features need to be identified in advance and manually coded. So basically the feature engineering part is done manually, and the problem is divided into parts and solved individually and then combined. So that is about the machine learning part. In deep learning basically enables machines to take decisions with the help of artificial neural networks. So here in deep learning we use neural nets. So that is the key differentiator between machine learning and deep learning. And usually deep learning involves a large amount of data, and therefore the training also requires, usually the training process requires high-end machines because it needs a lot of computing power. And the machine learning features or the feature engineering is done automatically. So the neural networks takes care of doing the feature engineering as well. And in case of deep learning, therefore, it is said that the problem is handled end to end. So this is a quick comparison between machine learning and deep learning in case you have that kind of a question. Then you might get a question around the uses of machine learning or some real life applications of machine learning in modern business, the question may be worded in different ways, but the meaning is how exactly is machine learning used, or actually supervised machine learning. It could be a very specific question around supervised machine learning. So this is like give examples of supervised machine learning, use of supervised machine learning in modern business. So that could be the next question. So there are quite a few examples or quite a few use cases, if you will, for supervised machine learning. The very common one is email spam detection. So you want to train your application or your system to detect between spam and non-spam. So this is a very common business application of supervised machine learning. So how does this work? The way it works is that you obviously have historical data of your emails, and they are categorized as spam and not spam. So that is what is the labeled information. And then you feed this information or all these emails as an input to your model, right? And the model will then get trained to detect which of the emails are to detect which is spam and which is not spam. So that is the training process. And this is supervised machine learning because you have labeled data. You already have emails which are tagged as spam or not spam. And then you use that to train your model, right? So this is one example. Now, there are a few industry-specific applications for supervised machine learning. One of the very common ones is in healthcare diagnostics. In healthcare diagnostics, you have these images and you want to train models to detect whether from a particular image, whether it can find out if the person is sick or not, whether a person has cancer or not. Right? So this is a very good example of supervised machine learning. Here, the way it works is that existing images, it could be X-ray images, it could be MRI or any of these images are available and they are tagged saying that, okay, this X-ray image is defective or the person has an illness, or it could be cancer, whichever illness, right? So it is tagged as defective or clear or good image and defective image, something like that. So we come up with a binary, or it could be multi-class as well, saying that this is defective to 10%, this is 25%, and so on. But let's keep it simple. You can give an example of just a binary classification, that would be good enough. So you can say that in healthcare diagnostics, using image, we need to detect whether a person is ill or whether a person is having cancer or not. So here, the way it works is you feed labeled images and you allow the model to learn from that, so that when new image is fed, it will be able to predict whether this person is having that illness or not, having cancer or not, right? So I think this would be a very good example for supervised machine learning in modern business. All right, then we can have a question like, so we've been talking about supervised and unsupervised, and so there can be a question around semi-supervised machine learning. So what is semi-supervised machine learning? Now, semi-supervised learning, as the name suggests, it falls between supervised learning and unsupervised learning, but for all practical purposes, it is considered as a part of supervised learning. And the reason this has come into existence is that in supervised learning, you need labeled data. So all your data for training your model has to be labeled. Now, this is a big problem in many industries or under many situations. Getting the labeled data is not that easy because there's a lot of effort in labeling this data. Let's take an example of the diagnostic images. We can just let's say take X-ray images. Now there are actually millions of X-ray images available all over the world, but the problem is they are not labeled. So the images are there, but whether it is defective or whether it is good, that information is not available along with it, right, in a form that it can be used by a machine, which means that somebody has to take a look at these images, and usually it should be like a doctor, and then say that, okay, yes, this image is clean and this image is cancerous and so on and so forth. Now that is a huge effort by itself. So this is where semi-supervised learning comes into play. So what happens is there is a large amount of data, maybe a part of it is labeled. Then we try some techniques to label the remaining part of the data so that we get completely labeled data, and then we train our model. So I know this is a little long winding explanation, but unfortunately there is no quick and easy definition for semi-supervised machine learning. This is the only way probably to explain this concept. We may have another question as what are unsupervised machine learning techniques? Or what are some of the techniques used for performing unsupervised machine learning? So it can be worded in different ways. So how do we answer this question? So unsupervised learning, you can say that there are two types, clustering and association. And clustering is a technique where similar objects are put together. And there are different ways of finding similar objects. So their characteristics can be measured, and if they have, in most of the characteristics, if they are similar, then they can be put together. This is clustering. Then association, I think the best way to explain association is with an example. In case of association, you try to find out how the items are linked to each other. So for example, if somebody bought maybe a laptop, the person has also purchased a mouse. So this is more in an e-commerce scenario, for example. So you can give this as an example. So people who are buying laptops are also buying a mouse. So that means there is an association between laptops and mouse. Or maybe people who are buying bread are also buying butter. So that is a association that can be created. So this is unsupervised learning, one of the techniques. Okay. All right, then we have very fundamental question. What is the difference between supervised and unsupervised machine learning? So machine learning, these are the two main types of machine learning, supervised and unsupervised. And in case of supervised, and again here, probably the keyword that the person may be wanting to hear is labeled data. Now, very often people say, we have historical data, and if we run it, it is supervised, and if we don't have historical data, yes. But you may have historical data, but if it is not labeled, then you cannot use it for supervised learning. So it's very key to understand that we put in that keyword labeled. Okay. So when we have labeled data for training our model, then we can use supervised learning. And if we do not have labeled data, then we use unsupervised learning. And there are different algorithms available to perform both of these types of trainings. So there can be another question, a little bit more theoretical and conceptual in nature. This is about inductive machine learning and deductive machine learning. So the question can be, what is the difference between inductive machine learning and deductive machine learning, or somewhat in that manner. So the exact phrase or exact question can vary. They can ask for examples and things like that, but that could be the question. So let's first understand what is inductive and deductive training. Inductive training is induced by somebody, and you can illustrate that with a small example. I think that always helps. So whenever you're doing some explanation, try as much as possible, as I said, to give examples from your work experience or give some analogies, and that will also help a lot in explaining as well, and for the interviewer also to understand. So here we'll take an example, or rather we will use an analogy. So inductive training is when we induce some knowledge or the learning process into a person without the person actually experiencing it. Okay, what can be an example? So we can probably tell the person or show a person a video that fire can burn his finger, or fire can cause damage. So what is happening here? This person has never probably seen a fire or never seen anything getting damaged by fire. But just because he has seen this video, he knows that, okay, fire is dangerous, and if fire can cause damage. Right? So this is inductive learning. Compared to that, what is deductive learning? So here you draw conclusion, or the person draws conclusion out of experience. So we will stick to the analogy. So compared to the showing a video, let's assume a person is allowed to play with fire. Right? And then he figures out that if he puts his finger, it's burning, or if he throws something into the fire, it burns. So he is learning through experience. So this is known as deductive learning. Okay, so you can have applications or models that can be trained using inductive learning or deductive learning. All right, I think probably that explanation will be sufficient. The next question is, are KNN and Kmeans clustering similar to one another, or are they same? Right? Because the letter K is kind of common between them. Okay. So let us take a little while to understand what these two are. One is KNN, another is Kmeans. KNN stands for K nearest neighbors, and Kmeans, of course, is the clustering mechanism. Now, these two are completely different except for the letter K being common between them. KNN is completely different. Kmeans clustering is completely different. KNN is a classification process, and therefore it comes under supervised learning, whereas K-means clustering is actually unsupervised. Okay, when you have KNN, when you want to implement KNN, which is basically K nearest neighbors, the value of K is a number. So you can say K is equal to 3. You want to implement KNN with K is equal to 3. So which means that it performs the classification in such a way that, how does it perform the classification? So it will take 3 nearest objects, and that's why it's called nearest neighbor. So basically based on the distance, it will try to find out its nearest objects that are, let's say, 3 of the nearest objects, and then it will check whether the class they belong to which class, right? So if all 3 belong to one particular class, obviously this new object is also classified as that particular class. But it is possible that they may be from 2 or 3 different classes. Okay, so let's say they are from 2 classes, and then if they are from 2 classes, now usually you take a odd number, you assign an odd number to. So if there are 3 of them and 2 of them belong to one class and then 1 belongs to another class, so this new object is assigned to the class to which the 2 of them belong. Now, the value of K is sometimes tricky. Whether should you use 3, should you use 5, should you use 7? That can be tricky because the ultimate classification can also vary. So it's possible that if you're taking K as 3, the object is probably in one particular class, but if you take K is equal to 5, maybe the object will belong to a different class, because when you're taking 3 of them, probably 2 of them belong to class 1 and 1 belong to class 2. Whereas when you take 5 of them, it is possible that only 2 of them belong to class 1 and 3 of them belong to class 2. So which means that this object will belong to class 2, right? So you see that? So the class allocation can vary depending on the value of K. Now, K-means, on the other hand, is a clustering process, and it is unsupervised, where what it does is the system will basically identify how the objects are, how close the objects are with respect to some of their features. Okay, but the similarity, of course, is the letter K, and in case of K-means also we specify its value, and it could be 3 or 5 or 7. There is no technical limit as such, but it can be any number of clusters that you can create. Okay, so based on the value that you provide, the system will create that many clusters of similar objects. So there is a similarity to that extent that K is a number in both the cases, but actually these two are completely different processes. We have what is known as naive Bayes classifier, and people often get confused thinking that naive Bayes is the name of the person who found this classifier or who developed this classifier, which is not 100% true. Bayes is the name of the person, B-A-Y-E-S is the name of the person, but naive is not the name of the person, right? So naive is basically an English word, and that has been added here because of the nature of this particular classifier. Naive Bayes classifier is a probability based classifier, and it makes some assumptions that presence of one feature of a class is not related to the presence of any other feature of maybe other classes, right? So which is not a very strong or not a very, accurate assumption, because these features can be related and so on. But even if we go with this assumption, this whole algorithm works very well even with this assumption, and that is the good side of it. But the term comes from there, so that is the explanation that you can give. Then there can be question around reinforcement learning. It can be paraphrased in multiple ways. One could be, can you explain how a system can play a game of chess using reinforcement learning? Or it can be any game. So the best way to explain this is, again, to talk a little bit about what reinforcement learning is about, and then elaborate on that to explain the process. So first of all, reinforcement learning has an environment and an agent, and the agent is basically performing some actions in order to achieve a certain goal. And these goals can be anything, either if it is related to game, then the goal could be that you have to score very high, score a high value, high number. Or it could be that your number of lives should be as high as possible. Don't lose lives. So these could be some of them. More advanced examples could be for driving. In the automotive industry, self-driving cars, they actually also make use of reinforcement learning to teach the car how to navigate through the roads and so on and so forth. That is also another example. Now, how does it work? So if the system is basically there is an agent and environment, and every time the agent takes a step or performs a task which is taking it towards the goal, the final goal, let's say to maximize the score or to minimize the number of lives and so on, or minimize the deaths, for example, it is rewarded. And every time it takes a step which goes against that goal, right, contrary or in the reverse direction, it is penalized. Okay, so it is like a carrot and stick system. Now, how do you use this to create a game of chess, or to create a system to play a game of chess? Now, the way this works is, and this could probably go back to this AlphaGo example where AlphaGo defeated a human champion. So the way it works is in reinforcement learning, the system is allowed, for example, if in this case we are talking about chess, so we allow the system to first of all watch playing a game of chess. So it could be with a human being or it could be the system itself. There are computer games of chess, right? So either this new learning system has to watch that game or watch a human being play the game, because this is reinforcement learning is pretty much all visual. So when you're teaching the system to play a game, the system will not actually go behind the scenes to understand the logic of your software, of this game or anything like that. It is just visually watching the screen and then it learns. Okay, so reinforcement learning to a large extent works on that. So you need to create a mechanism whereby your model will be able to watch somebody playing the game, and then you allow the system also to start playing the game. So it pretty much starts from scratch. Okay. And as it moves forward, it's right at the beginning, the system really knows nothing about the game of chess. Okay, so initially it is a clean slate. It just starts by observing how you're playing. So it will make some random moves and keep losing badly. But then what happens is, over a period of time, so you need to now allow the system, or you need to play with the system, not just 1, 2, 3, 4 or 5 times, but hundreds of times, thousands of times, maybe even hundreds of thousands of times. And that's exactly how AlphaGo has done. It played millions of games between itself and the system, right? So for the game of chess also, you need to do something like that. You need to allow the system to play chess and then learn on its own over a period of repetition. So I think you can probably explain it to this much, to this extent, and it should be sufficient. Now, this is another question which is again somewhat similar, but here the size is not coming into picture. So the question is, how will you know which machine learning algorithm to choose for your classification problem? Now, this is not only classification problem, it could be a regression problem. I would like to generalize this question. So if somebody asks you, how will you choose? How will you know which algorithm to use? The simple answer is, there is no way you can decide exactly saying that this is the algorithm I'm going to use. In a variety of situations, there are some guidelines. Like for example, you will obviously, depending on the problem, you can say whether it is a classification problem or a regression problem. And then in that sense, you are kind of restricting yourself to, if it is a classification problem, you can only apply a classification algorithm, right? To that extent, you can probably, let's say, limit the number of algorithms. But now within the classification algorithms, you have decision trees, you have SVM, you have logistic regression. Is it possible to outright say, yes, so for this particular problem, since you have explained this, now this is the exact algorithm that you can use? That is not possible. Okay, so we have to try out a bunch of algorithms, see which one gives us the best performance and best accuracy, and then decide to go with that particular algorithm. So in machine learning, a lot of it happens through trial and error. There is no real possibility that anybody can, just by looking at the problem or understanding the problem, tell you that, okay, in this particular situation, this is exactly the algorithm that you should use. Then the questions may be around application of machine learning. And this question is specifically around how Amazon is able to recommend other things to buy. So this is around recommendation engine. How does it work? How does the recommendation engine work? So this is basically the question is all about. So the recommendation engine again works based on various inputs that are provided. Obviously something like Amazon, a website or e-commerce site like Amazon collects a lot of data around the customer behavior, who is purchasing what. And if somebody is buying a particular thing, they're also buying something else. So this kind of association, right? So this is the unsupervised learning we talked about. They use this to associate and link or relate items. And that is one part of it. So they kind of build association between items, saying that somebody buying this is also buying this. That is one part of it. Then they also profile the users, right? Based on their age, their gender, their geographic location. They will do some profiling, and then when somebody is logging in and when somebody is shopping, kind of the mapping of these two things are done. They try to identify, obviously if you have logged in, then they know who you are and your information is available, like for example your age, maybe your gender, and where you're located, what you purchased earlier, right? So all this is taken, and the recommendation engine basically uses all this information and comes up with recommendations for a particular user. So that is how the recommendation engine works. All right, then the question can be something very basic, like when will you go for classification versus regression, right? When do you do classification instead of regression, or when will you use classification instead of regression? Now, yes, so this is basically going back to the understanding of the basics of classification and regression. So classification is used when you have to identify or categorize things into discrete classes. So the best way to respond to this question is to take up some examples and use it. Otherwise, it can become a little tricky. The question may sound very simple, but explaining it can sometimes be very tricky. In case of regression, we use, of course, there will be some keywords that they will be looking for. So just you need to make sure you use those keywords. One is the discrete values, and other is the continuous values. So for regression, if we are trying to find some continuous values, you use regression. Whereas if you're trying to find some discrete values, you use classification. And then you need to illustrate. What are some of the examples? So classification is like, let's say there are images and you need to put them into classes like cat, dog, elephant, tiger, something like that. So that is a classification problem. Or it can be, that is a multi-class classification problem. It could be binary classification problem, like for example, whether a customer will buy or he will not buy. That is a classification, binary classification. It can be in the weather forecast area. Now, weather forecast is again combination of regression and classification, because on the one hand, you want to predict whether it's going to rain or not. That's a classification problem. That's a binary classification, right? Whether it's going to rain or not rain. However, you also have to predict what is going to be the temperature tomorrow, right? Now, temperature is a continuous value. You can't answer the temperature in a yes or no kind of a response, right? So what will be the temperature tomorrow? So you need to give a number, which can be like 20 degrees, 30 degrees or whatever, right? So that is where you use regression. One more example is stock price prediction. So that is where again you will use regression. So these are the various examples. So you need to illustrate with examples and make sure you include those keywords like discrete and continuous. So the next question is more about a little bit of a design related question to understand your concepts and things like that. So it is, how will you design a spam filter? So how do you basically design or develop a spam filter? So I think the main thing here is he is looking at probably understanding your concepts in terms of what is the algorithm you will use, or what is your understanding about difference between classification and regression and things like that, right? And the process, of course, the methodology and the process. So the best way to go about responding to this is we say that, okay, this is a classification problem because we want to find out whether an email is a spam or not spam, so that we can apply the filter accordingly. So first thing is to identify what type of a problem it is. So we have identified that it is a classification. Then the second step may be to find out what kind of algorithm to use. Now, since this is a binary classification problem, logistic regression is a very common algorithm. But however, right? As I said earlier also, we can never say that, okay, for this particular problem, this is exactly the algorithm that we can use. So we can also probably try decision trees or even support vector machines, for example, SVM. So we will kind of list down a few of these algorithms and we will say, okay, we would like to try out these algorithms. And then we go about taking your historical data, which is the labeled data, which are marked. So you will have a bunch of emails, and then you split that into training and test data sets. You use your training data set to train your model or your algorithm that you have used, or rather the model actually. So, and you actually will have three models. Let's say you are trying to test out three algorithms, so you will obviously have three models. So you need to try all three models and test them out as well, see which one gives the best accuracy, and then you decide that you will go with that model. Okay, so training and test will be done, and then you zero in on one particular model, and then you say, okay, this is the model we will use, and then go ahead and implement that or put that in production. So that is the way you design a spam filter. The next question is about random forest. So what is random forest? So this is a very straightforward question. However, the response, you need to be again a little careful. While we all know what is random forest, explaining this can sometimes be tricky. So one thing is, random forest is kind of, in one way, it is an extension of decision trees, because it is basically nothing but you have multiple decision trees, and trees will basically we will use for doing, if it is classification, mostly it is classification, you will use the trees for classification, and then you use voting for finding the final class. So that is the underlines. But how will you explain this? How will you respond to this? So first thing, obviously, we will say that random forest is one of the algorithms, and the more important thing that you need to, probably the interviewer is waiting to hear, is ensemble learner, right? So this is one type of ensemble learner. What is ensemble learner? Ensemble learner is like a combination of algorithms. So it is a learner which consists of more than one algorithm or more than one maybe models. Okay, so in case of random forest, the algorithm is the same, but instead of using one instance of it, we use multiple instances of it, and we use. So in a way, that is a random forest is an ensemble learner. There are other types of ensemble learners where we have, like, we use different algorithms itself. So you have one maybe logistic regression and a decision tree combined together, and so on and so forth. Or there are other ways, like for example, splitting the data in a certain way and so on. So that's all about ensemble. We will not go into that. But random forest itself, I think the interviewer will be happy to hear this word ensemble learner. And so then you go and explain how the random forest works. So if the random forest is used for classification, then we use what is known as a voting mechanism. So basically, how does it work? Let's say your random forest consists of 100 trees, okay? And each observation you pass through this forest, and each observation, let's say it is a classification problem, binary classification 0 or 1, and you have 100 trees. Now, if 90 trees say that it is a 0 and 10 of the trees say it is a 1, you take the majority. You may take a vote, and since 90 of them are saying 0, you classify this as 0. Then you take the next observation and so on. So that is the way random forest works for classification. If it is a regression problem, it's somewhat similar, but only thing is, instead of vote, what we will do is, so in regression, remember what happens? You actually calculate a value. Right? So, for example, you're using regression to predict the temperature, and you have 100 trees, and each tree obviously will probably predict a different value of the temperature. They may be close to each other, but they may not be exactly the same value. So these 100 trees. So how do you now find the actual value, the output for the entire forest, right? So you have outputs of individual trees which are a part of this forest, but then you need to find the final output of the forest itself. So how do you do that? So in case of regression, you take like an average or the mean of all the 100 trees, right? So this is also a way of reducing the error. So maybe if you have only one tree, and if that one tree makes an error, it is basically 100% wrong or 100% right? But if you have, on the other hand, if you have a bunch of trees, you are basically mitigating that error, reducing that error. Okay, so that is the way random forest works. So the next question is, considering the long list of machine learning algorithms, how will you decide on which one to use? So once again, here there is no way to outright say that this is the algorithm that we will use for a given data set. This is a very good question, but then the response has to be like, again, there will not be a one size fits all. So we need to, first of all, you can probably shorten the list in terms of by saying, okay, whether it is a classification problem or it is a regression problem. To that extent, you can probably shorten the list, because you don't have to use all of them. If it is a classification problem, you only can pick from the classification algorithms, right? So for example, if it is a classification, you cannot use linear regression algorithm there. Or if it is a regression problem, you cannot use SVM, or maybe, no, you can use SVM, but maybe a logistic regression, right? So to that extent, you can probably shorten the list, but still you will not be able to 100% decide on saying that this is the exact algorithm that I'm going to use. So the way to go about is, you choose a few algorithms based on what the problem is. You try out your data, you train some models of these algorithms, check which one gives you the lowest error or the highest accuracy, and based on that, you choose that particular algorithm. Okay. All right. Then there can be questions around bias and variance. So the question can be, what is bias and variance in machine learning? So you just need to give out a definition for each of these. For example, bias in machine learning, it occurs when the predicted values are far away from the actual value. So that is a bias. Okay. And whereas they are all the values are probably, they are far off, but they are very near to each other though. The predicted values are close to each other, right? While they are far off from the actual value, but they are close to each other. You see the difference? So that is bias. And then the other part is your variance. Now variance is when the predicted values are all over the place, right? So if the variance is high, that means it may be close to the target, but it is kind of very scattered. So the predicted values are not close to each other, right? In case of bias, the predicted values are close to each other, but they are not close to the target. But here they may be close to the target, but they may not be close to each other. So they are a little bit more scattered. So that is what in case of a variance. Okay, then the next question is about, again, related to bias and variance. What is the trade-off between bias and variance? Yes, I think this is an interesting question, because these two are heading in different directions. So for example, if you try to minimize the bias, variance will keep going high. And if you try to minimize the variance, bias will keep going high. And there is no way you can minimize both of them. So you need to have a trade-off saying that, okay, this is the level at which I will have my bias, and this is the level at which I will have variance. So the trade-off is that pretty much that you decide what is the level you will tolerate for your bias and what is the level you will tolerate for variance, and a combination of these two in such a way that your final results are not way off. And having a trade-off will ensure that the results are consistent, right? So that is basically the output is consistent, and which means that they are close to each other, and they are also accurate, right? That means they are as close to the target as possible, right? So if either of these is high, then one of them will go off the track. Define precision and recall. Now again, here I think it would be best to draw a diagram and take the confusion matrix, and it is very simple. The definition is like a formula. Your precision is true positive by true positive plus false positive, and your recall is true positive by true positive plus false negative. Okay, so that's, you can just show it in a mathematical way. That's pretty much that can be shown. That's the easiest way to define. So the next question can be about decision tree. What is decision tree pruning and why is it? So basically, decision trees are really simple to implement and understand, but one of the drawbacks of decision trees is that it can become highly complicated as it grows. Right? And the rules and the conditions can become very complicated, and this can also lead to overfitting. which is basically that during training you will get 100% accuracy, but when you're doing testing you will get a lot of errors. So that is the reason pruning needs to be done. So the purpose or the reason for doing decision tree pruning is to reduce overfitting or to cut down on overfitting. And what is decision tree pruning? It is basically that you reduce the number of branches, because as you may be aware, a tree consists of the root node, and then there are several internal nodes, and then you have the leaf nodes. Now if there are too many of these internal nodes, that is when you face the problem of overfitting, and pruning is the process of reducing those internal nodes. Alright, so the next question can be, what is logistic regression? So basically logistic regression is one of the techniques used for performing classification, especially binary classification. Now there is something special about logistic regression, and there are a couple of things you need to be careful about. First of all, the name is a little confusing. It is called logistic regression, but it is used for classification. So this can be sometimes confusing, so you need to probably clarify that to the interviewer if it's really, if it is required. And they can also ask this like a trick question, right? So that is one part. Second thing is, the term logistic has nothing to do with the usual logistics that we talk about, but it is derived from log. So that the mathematical derivation involves log, and therefore the name logistic regression. So what is logistic regression and how is it used? So logistic regression is used for binary classification, and the output of a logistic regression is either a 0 or a 1, and it varies. So it's basically, it calculates a probability between 0 and 1, and we can set a threshold that can vary. Typically it is 0.5. So any value above 0.5 is considered as 1, and if the probability is below 0.5, it is considered as 0. So that is the way we calculate the probability, or the system calculates the probability, and based on the threshold it sets a value of 0 or 1, which is like a binary classification, 0 or 1. Okay, then we have a question around k nearest neighbor algorithm. So explain k nearest neighbor algorithm. So first of all, what is a k nearest neighbor algorithm? This is a classification algorithm. So that is the first thing we need to mention. And we also need to mention that the k is a number. It is an integer. And this is variable, and we can define what the value of k should be. It can be 2, 3, 5, 7, and usually it is an odd number. So that is something we need to mention. Technically it can be even number also, but then typically it would be odd number, and we will see why that is. Okay. So based on that, we need to classify objects. Okay, we need to classify objects. So again, it will be very helpful to draw a diagram. If you're explaining, I think that will be the best way. So draw some diagram like this, and let's say we have 3 clusters or 3 classes existing, and now you want to find for a new item that has come, you want to find out which class this belongs to, right? So you go about, as the name suggests, you go about finding the nearest neighbors, right? The points which are closest to this, and how many of them you will find, that is what is defined by k. Now let's say our initial value of k was 5. Okay? So you will find the 5 nearest data points. So in this case, as it is illustrated, these are the 5 nearest data points. But then all 5 do not belong to the same class or cluster. So there are one belonging to this cluster 1, the second one belonging to this cluster 2, 3 of them belonging to this third cluster. Okay. So how do you decide? That's exactly the reason we should, as much as possible, try to assign an odd number so that it becomes easier to assign this. So in this case, you see that the majority, actually, if there are multiple classes, then you go with the majority. So since 3 of these items belong to this class, we assign, which is basically the, in this case, the green or the tennis or the third cluster, as I was talking about. Right? So we assign it to this third class. So in this case, it is that's how it is decided. Okay. So k nearest neighbors. So first thing is to identify the number of neighbors that are mentioned as k. So in this case, it is k is equal to 5. So we find the 5 nearest points, and then find out of these 5 which class has the maximum number in that. Okay. And then the new data point is assigned to that class. Okay, so that's pretty much how k nearest neighbors work.
Today we are going to talk about some of the essential programming interview questions for a data scientist role. Now, since Python is widely used programming language for data science, machine learning and deep learning, we will be solving our problems in the Python programming language using Jupyter Notebook. So let's begin with our first question. Our first question is, how do you get a list of all the keys in a dictionary? Now in Python for data science, data structures play an important role to store and manipulate data. Dictionary is one such data structure that is declared using curly braces, and they are written as key value pairs. You can see on the screen I have my dictionary called D, and it is assigned using curly braces. Now to get a list of all the keys in a dictionary, we use the .keys function. Now let me take you to my Jupyter Notebook. So here is my Jupyter Notebook, and you can see my first cell. I have my dictionary defined. So the name of the dictionary is D, and it has the key values. The keys are the country names and the values are the capitals of each country. So I have India and the capital is New Delhi. Then I have USA, the capital is Washington. Similarly, I have Spain, Madrid, and we have Germany and Berlin. Now India, USA, France, Spain, all these are my keys. So to get the keys, I'll use the .keys function. So I'll write my dictionary name, that is D dot, I'll give keys, close the brackets and hit Shift Enter. You can see these are the list of my keys in the dictionary D. Alright. Okay. Now let's move to our next question. So our next question is, what do you mean by list comprehension in Python? So list comprehensions are a short and easy way to define and create new lists based on existing lists. So suppose you want to iterate through a list and find all the even numbers in the list. You can either use a for loop and an if condition as shown here, or you can write a list comprehension to do it in one line of code. You can see this is my list comprehension. So let me show you both the ways. Alright, so here on my Jupyter Notebook, let me declare my list as L equal to, I'll pass in a few numbers, let's say 5, 12, 10, we have 14, 43, 11, 7, 9, and let's say the last element in the list is 6. Alright, let me run this list. Okay, now let me create an empty list. Let's say list 1, and let this be an empty list with square brackets. Then I'll use the looping construct to find the even elements in the list. So I'll write a for loop called for item in my list L. I'll give colon, then I'll give my condition if item percentage 2 is equal to 0, which means if the remainder is 0, then I'll append the items to my empty list, which is list 1. So I'll write list1 dot append, and I'll pass in the argument my item. Now let me go ahead and print my list. I'll write print the final list using a for loop. I'll give colon, give a comma, and pass in my new list name, which is list 1. Now let's run this. You can see using this for loop and the if condition, I have got all the even elements in my list, which was L. You can see my original list, and 12, 10, 14 and 6 were all the even numbers present in my list. Now this task, you can do it using list comprehensions as well. So let me show you how to do that. So I have my list defined. Let me just copy this here. I'll paste it. And now I'll create another variable which is list1. I'll write equal to. Now here, using square brackets, I'll write item for item in L, and I'll give my if condition as if item percentage 2 is equal to 0, then I'll print my resultant list. So I'll write print, let's say, resultant list using list comprehension. I'll give a colon, then a comma, and I'll pass in my new list, which is list1. So here, whatever is there in my square brackets is called the list comprehension technique. Let me just print this and I'll get the same result. So these are my even numbers. Alright, so let's move to the third question. So our third question is, given a list of numbers, find the squares of the numbers using the map function in Python. Now the map function calls the specified function for each element of an iterable and returns a result. So let me show you an example to find out squares of a list of numbers using the map function. Okay, so let's first define a function called square. So I'm using my def keyword and I'll pass in my user defined function name as square, and I'll give my parameter as x, and I want to return the square of x, which is x star x. Alright, and then let me define my list of numbers. So I'll pass in a variable called num, and let's say I want to find the squares of 5 numbers 1, 2, 3, 4, 5. Here I'll pass in another variable which will store the resultant list. So I'll write num underscore squared equal to, here I'll use my map function. So map function takes in two parameters. First it will take in the user defined function name, which is square here, and the list of numbers, which is num. I'll run a for loop. I'll write for, let me just scroll down. I'll write for num in num underscore squared print num. So this is my map function. So it will map all the elements in the list to this function, which is square. I'll just print it. You can see we have the list of squares from the num list, which has the elements 1, 2, 3, 4 and 5. Now moving ahead, coming to our fourth question. The fourth question is on to write a program that will filter out the numbers divisible by 3 from a tuple using the lambda functions. So lambda functions are anonymous functions that are not defined by the def keyword in Python. So here you can see I have the example. So this is a tuple I have defined, and using filter along with the lambda function I am trying to find out the numbers that are divisible by 3, and finally I am printing those numbers. So let's do it on our Jupyter notebook. Alright, so we are on the Jupyter notebook. So first I'll define a tuple. Let's say the variable name is my underscore tup, which stands for my tuple, and using brackets I'll pass in my tuple values. Let's say 5, 12, 10, 18. We have 43, 9, 7, 11 and let's say 6. So you can see these are the numbers present in my tuple. Now I'll create another variable called new tuple, and I'll use my tuple function, and inside the tuple function I'll use the filter function that will filter out only the values that are divisible by 3. And now I'll write my lambda function. So notice this clearly how to use a lambda function. I'll use the keyword lambda, and then I'll pass in a variable x, Now this should consider only those values that are divisible by 3. So I'll write x percentage 3 should be equal to 0, and I'll give my tuple as the variable here. Alright, now we have declared our lambda function. Let's just go ahead and print my new tuple, which is new underscore tup. So here you can see I have my tuple function. Inside the tuple function, I'll use my filter function that will filter only those values divisible by 3. And to filter those values, I have used my lambda function here and passed in my original tuple, which is my tuple. It's actually my tup. So let's delete the last 2 letters. Let's just go ahead and print this. There you go. You can see we have 12, 18, 9 and 6 are the only numbers that are divisible by 3 from this tuple. Moving to the next question. So our next question is how to create a data frame from a dictionary. Now to create a data frame from a dictionary, you can use the pandas library and the .dataframe function. Now pandas is a popular library in Python that is used for data manipulation. So let me show you how you can create an employee dictionary and then convert that into a data frame. Okay, so here on my Jupyter notebook, let me go ahead and import my pandas library. So I'll write import pandas as pd, and next let's create my employee dictionary. So I'll write emp, which stands for employee, and within curly braces I'll give my key value pairs. So my first column would be the name of the employee, and let's pass in a list of employee names. I'll write Amy. Let's say we have Angela. The third employee's name, let's say we have Samuel, and let Danny be our fourth employee. I'll give a comma. Now the second attribute in our dictionary will be the age of the employee. So my key would be age, and let's create a list of age values. I'm assigning random values to those employee age, 30 and let's say 32. And let's create another variable called city. Here variable refers to the column name of the data frame. Let's say Amy is from New York. Then we have Angela from Chicago. Let's say Samuel is from Boston, and we have Danny from, let's say, Seattle. Okay, so if I run this, I have my employee dictionary created. So if you want to see the dictionary, you can write print and pass the variable name, which is emp here. So this is my dictionary. Now to convert this dictionary into a data frame, you can simply write df, and you can give the pandas library as pd and use the data frame function. So I'll write data frame, and I'll pass in my dictionary name, which is emp here. Let's run it. Okay, so we have successfully created our data frame. Now let me just print the data frame. I'll write df. There you go. You can see I have a nice table here, which is actually a data frame. Here you can see the indices, and you can see our column names as name, age and city, and these are the values or the rows. Alright. Now let's see the sixth question we have. So the question is, what is the difference between LOC and ILOC in Python? Now as data scientists, you would often want to analyze a chunk of data and not all the rows in it. So LOC and ILOC functions can help you fetch specific rows and columns from your data frame. LOC function uses row or column labels to select and slice data from a data frame, while ILOC uses integer index to select specific rows and columns. Remember, ILOC stands for index location. I'll use a car data frame to show how LOC and ILOC works. Now on your screens you can see the data frame. So it has a column called brand, which has different brand names such as Ford, there's Hyundai, Tata, Mahindra, there's Maruti, there's Kia Motors. Then we have the year in which the car was manufactured. We have the number of kilometers the car has run. We have the city and the mileage the car gives. So let me first create this data frame on my Jupyter notebook. Okay, so here on my notepad I have my code written to create the data frame, that is car. I'll just copy this code and I'll paste it to this cell. Okay, let me just run it. So if I go on top, you can see we have successfully created our car data frame. Now let me go ahead and print this data frame. So I'll write print, in brackets I'll give my data frame as car. Let me run it. Alright, so here is my data frame. Now suppose you want to see the data from second row till the fifth row for brand and city columns, so you can use the LOC function. So I want my data from the second row till the fifth row for brand and city columns. So let me show you how to do that. So first I'll write my data frame name, that is car, and then I'll give my function as LOC, and within brackets I'll give my row index values. So I'll give from 2 to 5, which is second row to fifth row, and I'll give my column names as brand. I'll give a comma, and my second column which I want is city. So here I'm using the labeled based indexing. Let me just run it. There you go. You can see we have the information available for the second row, third row, fourth row and the fifth row. Alright. Similarly, let's see one more example for index location based slicing. So suppose you want to see the data from second, third and fourth row for year, kilometers and city columns. So for that you can use the ILOC function. So I want the value for second, third and fourth row, and the columns that I want are years, kilometers and the city column. So for that I'll give my data frame name as car dot, this time I'll use ILOC, and within square brackets I'll give my row values and the column values. Now one thing you should notice here is, if you use ILOC, Python will exclude the last index, which is the fifth row, and similarly here it will exclude the last index from the column, which is the fourth column. If I run this, you get the desired result. Now let's see another example. Let's say this time I want to print the rows that have mileage less than 25 for brand and city columns. So you can use a print function, and I'll pass in my data frame as car and use LOC. Here I'll give my condition as car, and I want my condition, that is mileage should be less than 25, and I want the brand name. So I'll use a square bracket and give my brand column, and I also want the city column. Okay, let me close it. If you run this, now these are the brand names Renault, Tata and Kia, which have mileage less than 25. Let me just verify this. You can see all these values are less than 25. Similarly, you can use the ILOC function as well.
I can write print. I'll give car dot ILOC. Within square brackets, I'll give car, and my condition column is mileage. Now this should be less than 25. I'll use dot values, and then I'll give my column numbers as 0, 2. Let me run it. There you go. The same result, we have got it using ILOC function this time. And you can see the columns were 0, 2, which means we wanted the first column, which is brand, and the second column, which was kilometers. Alright. Now moving to our 7th question in the list of questions that we have. The question is, how is list.append different from list.extend? Now list.append adds its arguments as a single element to the end of the list. The length of the list increases by 1 here. And list.extend iterates over its arguments and adds each element to the list. The length of the list increases by the number of elements in its arguments. So let me show you the difference on my Jupyter notebook. Okay, so let's create a list called list1 equal to, I'll create a list, let's say it has some country names like India, then we have USA, and I'll consider one more country, let's say Canada. Okay, now let me print the length of this list also. I'll use the length function for that. Alright, now let me append one more list. So I'll use the append function. I'll write list1 dot append, and within brackets I'll give my new list which has two more country names, let's say France and Spain. Okay, and here let me print list1, and let's also print the length of the list again. I'll use the length function and my list name, which is list1. So just mark we are using append here. Let me run this. There you go. So here you can see my original list had 3 elements, hence the length is 3. Now when I appended this new list which had 2 elements, France and Spain, our size increased by 1 and the length of the new list is 4. Now let me just copy this code, and instead of append let me write extend, so that we can see the difference between append and extend. I'll just scroll down, run it. Here you can see our original list had 3 elements, but after we extended our list with 2 more elements, the length of the new list became 5. So these are the 5 elements in the list, and here you can see there were total 4 elements in the list when we appended the new list. Okay, now moving to our 8th question. Suppose you have a car dataset which has a mileage column. You need to create a new field called MLG that will accept 2 values. If mileage is less than 25, then the mileage should be high MLG, or the value should be high MLG. Now while analyzing data, data scientists often need to create extra columns in the data frame to add more values that will help you make your data analysis more efficient. So here you can see my data set. It has the brand name, year, kilometers, city, and the mileage column. Now if mileage is less than 25, I'll add the value low MLG to my new column. Else, if mileage is greater than or equal to 25, I'll add high MLG to my new column. So here you can see my final output. Wherever the mileage is less than 25, it should print low MLG, else it should print high MLG. Now let's do this on my Jupyter notebook. So we'll use lambda functions that we learned earlier to perform this task. I'll write a function, let's say f is equal to, you can call this as a function or a variable. I'll give the keyword lambda and use x as my parameter. Now x should be low MLG if x is less than 25, which is mileage here, else if it's not less than 25, it should return high MLG. Now what I'll do is I'll give my data frame as car and I'll create my new column, that is MLG. Then I'll write equal to car dot, I'll give my column name from the original data frame, which is mileage, and I use my apply function and pass in the variable f. Now let's just print this data frame. If I run it, you can see the output here. We have created a new column which is MLG. You can see our new column name was MLG, and these are the results. So for Renault, Tata and Kia, for the last 3 rows, since the mileage is less than 25, it returned low MLG. For the remaining, it gave us high MLG. Now moving to the 9th question. So this is our next question. We want to create a 4x4 matrix and find the sum of all the diagonal elements in the matrix. Data scientists often work with multiple dimensional arrays or multi-dimensional arrays and matrices to build models. This question is related to an operation on a 4x4 matrix. So first, we need to create an array which will be a NumPy array of 4x4 shape, and then we'll see how to calculate the diagonal elements or the sum of the diagonal elements. So I am on my Jupyter notebook. First, let's import the NumPy library. So I'll write import NumPy or NumPy as np. Let me run it. Okay. Now I'll create my 4x4 matrix. So I'll write m is equal to np dot array, and I'll create my 4x4 matrix. Let's say the values are 1, 2, 3, 4 in the first row, and in the second row I'll pass 5, 6, 7, 8. In the third row we'll have 9, 10 and 11, also 12, and finally we'll have 13, 14, 15 and 16 in the fourth row. I'll just run it. Now if I print m, you can see this is a 4x4 matrix. So this is one way of creating a 4x4 matrix, which is a bit tedious and lengthy. Instead of that, you can also use arange function. So if I write m is equal to np dot arange function, and here I'll give my values starting from 1 till 17. So this will actually exclude 17 and take from 1 to 16, and I'll give my shape as 4, 4. Let me print it. There you go. It has printed the exact same matrix that we saw above. Alright. Now to print the diagonal elements, we'll use the diagonal function. So I'll write print m dot diagonal. Let me just run it. So 1, 6, 11 and 16 are my diagonal elements. You can see this matrix. 1, 6, 11 and 16 are my diagonal elements. Now to print the sum of all the diagonal elements, I'll use the sum function. So I'll write m dot diagonal, Along with that, I'll pass my sum function. If I run it, so the sum of 1, 6, 11 and 16 is 34. Okay, so coming to the last question on this interesting session on programming interview questions for data scientists. Our question is, given a vehicle data frame, find the average and maximum mileage of the vehicles using pandas. So here, data scientists use statistical measures to analyze their data, so it is important to have knowledge of the statistical functions in Python. Here is my vehicle data set, and for each brand of vehicle we want to find the average and the maximum mileage. So let me show you how to do it. Okay, so here on the notepad I have my code written to create the vehicle data frame. I'll just copy it and paste it on this cell. You can see we have the brand column, the year column, kilometers, city, mileage. Here you can see the different brand of vehicles. Let me just create this data frame first, and let me go ahead and print the vehicle data frame. So I'll write vehicle and run it. So here is the data frame. Now I want to find the average and maximum mileage for each of the brand, and then I'll use my data frame name as vehicle followed by the group by function. I'll write group by, and since I want to check for all the brands, so I'll group all the brand of vehicles. Then I'll use an aggregate function which is agg, and within curly braces I'll give my column as mileage. I'll give a colon and pass in mean, which is for average, and I'll use max to find the maximum mileage. Now let's print it. I'll write print. I'll give a message as the average and maximum mileage of vehicles. Let me just print the result. I'll run it. You can see it has resulted in an error. The reason is in vehicle the V is capital. Now if I run it, there you go. Here you can see on the left we have the brand names. We have Hyundai, there's Maruti and Tata, because those were the only 3 brand of vehicles we had. And for each brand you can see the mean mileage and the maximum mileage. For Maruti it was 26.33 and the maximum mileage is 28. Similarly you can see for Tata vehicle as well. SQL is a widely used language for querying data from databases. It allows you to store, retrieve, manipulate and update data present in the form of rows and columns. Data scientists often work with structured data that is stored in MySQL databases, Microsoft SQL servers, Oracle databases, or even NoSQL databases such as MongoDB. Today, we will look at a variety of SQL questions. We'll be using the MySQL database for our demo. Throughout the video, we'll be using MySQL Workbench and the MySQL command line to solve the SQL queries. Let me show you the database that we will be using for this demo and the tables we are going to use. Okay, so here I am on my SQL Workbench, and below you can see I have a local instance created. I'll just click on it. Now it's asking me to enter the password. I'll give my password and hit OK. Now this will take me to the SQL editor. Now this is the SQL Workbench. So let me first create a new SQL query file. Alright, so first and foremost, let me show you the databases we have. For that, I'll use the command show databases. If I hit tab, it will autocomplete. I'll give a semicolon and hit Control Enter to run this. There you go. Here you can see the list of databases that we already have, and
from the list of databases, we are going to use the SQL_IQ database. So to use this database, I'll write the command use SQL_IQ. I'll give a semicolon. I'll select this and I'll click on this execute button. If I run this, you can see now I'm using SQL_IQ database. Now if you want to see all the tables present in SQL_IQ database, we'll use the following command. So I'll write show tables. Now this will list all the tables present inside SQL_IQ database. If I run it, you can see here it has executed successfully and it has given us 7 rows, which means we have a total of 7 tables in this database. You can see there's an author table, there's a table called books, we have customers, email, employee, players, and weather table. So all these tables we are going to use in the course of this video. Now if you want to have a look at the data present in one of the tables, you can just use the select statement. So I'll write select star from, let's say I want to see the data present inside the employee table, so I'll write employee. So this is my table name. I give a semicolon. If I select this, hit the execute button, there you go. It shows me that it has returned 6 rows, and these are the column names. We have the name of the employee, the age of the employee, we have the employee's salary and the employee ID. So there are total 6 employees in the table. Alright. Now I can do the same operations on my SQL command line as well. Now let me open the command line first. Okay, so this is the MySQL command line client. It is asking me to enter the password, so I'll give my password first. Alright, now here you can see I have come inside MySQL. Now the operations that we performed on the MySQL workbench, the same operations can be performed on the command line as well. So I'll write use SQL_IQ. I'll hit enter. You can see the message, it says database changed. Now if you want to display the tables present inside this database, I can use show tables command. I have to give a semicolon and hit enter. There you go. You can see the list of tables we have inside the database. Now if you want to have a look at the content of one of the tables, I can just write select star from, let's say, players. If I give a semicolon, hit enter, you can see the rows and columns in the dataset. Alright, and with that, let's move on to our first question on SQL. Okay, so our question is, what is the difference between where and having clause in SQL? So where clause is used to filter the records based on the specified condition, while the having clause is used to filter the records from groups based on specified conditions. You need not worry, we'll do the demo for where and having clause using the employee table. So where clause cannot have aggregate functions such as count, sum, min or maximum functions. Having clause can operate on aggregate functions. Now where clause is implemented on rows, while having clause is implemented on columns. Now let me show you an example of how a where clause is different from an having clause. So I'll take you to my MySQL workbench. Alright, so we are on the SQL workbench. So suppose I want to get the records of the employees whose age is greater than 30. For this, I can use a where clause. So since I want to get the employees whose age is greater than 30, I'll use a where clause. I'll write my SQL query as select star from employee where I'll write age is greater than 30. If I give a semicolon and run this, it will return all the employees whose age is greater than 30. You can see 36, 36 and 35. These are the employees whose age is greater than 30. Now I have intentionally kept some duplicate rows because we are going to use this in our next questions. Again, I can also do the same task using the having clause. So let me just copy this query. I'll paste it here. Now instead of where, I'll write having. So you will see that even this query will return the same result. If I run it, you can see it gives me the same result. Now let's say I want to find all the records where the count of age for all the employees is greater than 1. In this case, I can't use a where clause. It will throw me an error since where clause cannot be used with aggregate functions. So let's try using an aggregate function in the where clause. So I'll write select star from employee where count of age is greater than 1. So the idea is to find all the records where the count of age for all the employees is greater than 1. So if I run this SQL query, you can see it has given me an error. It says invalid use of group function. Now instead, we need to use a having clause along with the group by clause to solve the problem. So I'll group all the age values and then find the count of each age value. So let me just paste this, and here I'll edit my SQL query. Instead of where, I'll write having, and just after the table name I'll use the group by clause. So I'll write group by age. Now let's run it. Alright, you can see our SQL query has returned only those employees whose age occurs more than once. Now let me just verify this. If I run my employee table, you can see Angela's age, that is 36, has been repeated twice. You can see Angela here as well, and similarly we have Mike also repeated twice. Alright. Now let's see the second question. Now this is a multiple choice question where you need to answer the correct SQL query based on the question. So the question is, the correct SQL query to select all the records of employees with ARI in their names is. So we have a list of 4 options given, and out of that you need to find the correct option. Now the answer to this question is this. So if you write select star from the table name, which is employee here, where name like, then if you give this condition, it will return all the records where employees have ARI in their names. Now like is an operator in SQL that is used to search a specified pattern. So here our pattern is we want all those employees who have ARI in their names. The first percentage means that the name can have any number of letters in the beginning, followed by ARI in the middle, and the last percentage means the name can have any number of letters in the end. So let's do this on our MySQL workbench. Let me first display all the employees in the table. So I'll write select star from employee. I'll run this. If you see my table, I have one employee who has ARI in its name, and that person is Karin. I now want to get this particular record. So what I can do is I'll write a select query, select star from employee where name, then I'll use the like operator where name like, within double quotes I'll give percentage ARI, again a percentage, close the double quotes and give a semicolon. If I run this, you can see my SQL query will return only Karin. Now let's do one more example. Suppose I want to find the employee whose name starts with D. So the way to do is something similar to what we saw just now. So here in my condition, I'll just replace this with D. This means the name should start with D, and after that it can contain any number of letters. Now let's run it. There you go. So our table had one employee called Danny whose name started with D. Now moving to our third question. So the question is, we want to write a query to find the players with the least number of goals. So there are two methods to do it. One where you can use a subquery, and the other method to use the limit operator. So let me show you both the methods. First, let me go ahead and display all the tables present in my database, that is SQL or SQL_IQ. Alright, if I scroll down, you can see we have a table called players. So I'm going to use the players table to find the player with the least number of goals. So let me show you the first method, that is by using a subquery. So I'll write select star from my table name, which is players, where goals equal to, and in this I'll write my subquery using brackets. So I'll select minimum goals from the table, that is players. I'll close the bracket and then I'll give a semicolon. Now let me go ahead and run this. You can see Matt was the player from Scotland who scored the least number of goals, that is 3. Now let's break it down. So what we did was, first my SQL query found out what was the minimum goal scored by a player. So if I run this, you will see it will return me 3. So 3 was the least number of goals scored by one of the players. Now in my outer query, what SQL did was it searched for those goals where the value was equal to 3. So we wrote select star from players where goals equal to 3. Hence, if I run this, you will find the player who scored only 3 goals, and that player is Matt. Alright. Now the other way to do is using the limit operator. So this is more simpler than the previous method. I can write select star from players, order by goals. Now let me first run this SQL statement. If I run this, you can see we have ordered this in ascending order. So the person who has scored the least number of goals appears at the top, and the person with the player with the highest number of goals appears at the bottom. And from this table I only want the first row, and for that I can use the limit operator. So if I write limit 1, it will display only the first row. If I run it, you can see it shows me only the record for Matt. Moving ahead, now let's see the fourth question in our list. The question is, write the SQL query to find the player with the second highest number of goals. Now again, there are two methods to do it. One is by using limit and offset, and the other method is to use a subquery. So let's see both the methods. I'll first write my SQL query using limit and offset. So my query will be select star from players, order by goals, descending. Let me just run this. Alright, so here you can see my table has been ordered in descending order of goals. So Anthony has scored the most number of goals, then comes Daniel, followed by Sam, and at the end we have Matt, who scored the least number of goals. Now out of this, I want the player who scored the second highest number of goals, which is Daniel. So I want my SQL query to return this row.
that has player ID 103, name is Daniel, country is England, and goals is 7. For that, MySQL has two features, so I can use limit 1 followed by offset 1. So what this query does is, it will offset one row, that is, it is going to offset the first row, or it is going to skip the first row and then print only the second row because I have set my limit to 1. So let me just run it. You will see we get the desired result. The player name is Daniel and the number of goals scored is 7. Now the other method to do is using a subquery. Now let me write my subquery. First I'll write my outer query, which is select star from, and here I'll write my subquery select star from players order by my column name, which is goals, in descending order. Here I'll limit it to 2. Then I'll give my alias name as T. Then I'll use order by goals limit 1. Let me just run it first. If I run this, you see here I get the same result. Now let's first break it down. I'm going to run this subquery first. So here I have select star from players order by goals descending and limit is 2. Let me just run it. So the selected SQL query returns the first 2 rows ordered by goals, and if you see here clearly, we have again ordered the value returned in ascending order, which means from this table, if I order this table in ascending order, Daniel should appear first, and out of that I am limiting my result to 1, so it will print only Daniel. If I run this again, you can see I have the desired output. Now let's check the 5th question in our list. Given the below email table, write a SQL query to find the distinct domain names from the email column. So if you consider this as my email table, the domain names are gmail.com, yahoo.in, and we have hotmail.com. These are the distinct domain names. Now to solve this task, again we have two methods. Either you can use the substring underscore index function, or you can use the substring function. Now the substring underscore index function returns a substring of a given string before a specified number of delimiters. So let me first use the first method. Okay, so here on my SQL workbench, I'll write select. I'll use the keyword that is distinct. Then I'll use my function, which is substring underscore index. Here substring underscore index will take 3 parameters. The first is the original column name, which is email, followed by the delimiter I am looking for, that is @. So I'll put @ with single quotes since it is a text or a character, and then I'll give the number of times to search for the delimiter. Here it is going to be -1. So you can either give a positive value or a negative value. If it is a positive number, then this function will return all to the left of the delimiter. If it is a negative number, the function returns all to the right of the delimiter. Alright. And then I'll give an alias name as, say, domain name from my table, that is email. If I run this, you can see I have the list of all unique domain names or distinct domain names that we saw in our table. This is one of the ways. The other way is to use the substring function. Now the substring function extracts a substring from a string starting at any position. So let me write my SQL query. I'll write select distinct. I'll then give my function as substring.
Here substring will take in two parameters. The first parameter is the column name, which is email ID here. So I'll write email. I'll give a comma. Next, I want to find my delimiter. So for that, I'm going to use another function called locate. And here I want to locate the index position of @. So I want to give my delimiter as @ followed by the column name, which is email. And then I want to fetch everything after the delimiter, and for that I'm giving +1. Again, let me give a domain name as the alias name from email. If I run this, you will see we'll get all the unique domain names: Gmail, Yahoo.in and Hotmail.com. So these were the two ways to solve the same problem. Now moving ahead, let's look at our sixth question. So our question is, write the SQL query to find duplicate records from a table without using a temporary table. Now, one of the other variants of this question is to delete all the duplicate records from a table without using a temporary table. Now to solve such queries, you can use the group by and the having clause. Let's look at how to do it. So here on my SQL workbench, I'll write my select query as select star, and then I want to count all the duplicate values. Let me give it an alias name as frequency from my table name, which is employee here. And then I want to group by name having count star greater than 1. Let me just run it. Alright, you can see it has returned me two rows. The name is Angela and Mike, and the frequency is 2. Let me just verify this to see all the repeated records that were present in my employee table. So I'll write select star from employee. If I run this and scroll down, here you can see Angela is present here as well as at the bottom. Similarly, we have Mike present twice in the table, and hence our SQL query returned only Angela and Mike because they were repeated twice. You can see the frequency here. So let's now look at our seventh question. Given the below employee table, I want to write a query to find all the even and odd records from the table. So as you can see, there are two ways to do it. One is to use a subquery, and another you can use the mod function. So let me show you both the ways. Alright, so let me run this SQL query to see all the values present in the employee table. So if you see, the last column, which is the employee ID column, has all the employee IDs as unique values. So I'm going to use this in my where condition. So to find out all the even records, I'll write my SQL query something like this. I'll write select star from employee, which is my table name, where employee ID, then I'm going to give my in operator, and inside the in operator I'm going to write my subquery, which is select employee ID from employee, where employee ID %2 is equal to 0. This means wherever my employee ID is divisible by 2, it will return only those records. So let me just run it. There you go. So here we have easily fetched only the even records from the table. Similarly, if you want to get only the odd records from the table, you can use the mod function also. So I'll write select star from employee, where here I'm using the mod function.
mod empid comma 2 is not equal to 0. So I'll use the exclamation mark is equal to 0. So if I run this, it will return only the odd employee IDs. You can see it here. So those were the two ways in which you can fetch the even and odd records from the table. Now let's see our 8th question. So here is the question. Below is the customer table. Write a query to get the first purchase of each customer. Now if you look at the table, there are 3 customer IDs, 101, 102 and 103. Now customer 101 made its first purchase on 2nd October 2018, which is this one, and customer 102 made its first purchase on 5th of October 2018. And since we have just one record for customer ID 103, so this is going to be his or her first purchase. So I want to return 101 phone, 102 tablet and 103 books. To do this, we are going to use an inner join. If you can see, I have used an inner join and I have also used a subquery. Let's write this query on my SQL workbench. Okay, so this query is going to be a little complicated. If you have any questions, then please put it in the chat section. We'll be happy to help you. So I'll start with select. I'm going to take an alias name as t dot. I'll write cust underscore id comma t dot purchased at comma, the next field I'm going to select is t dot item from customers as t. Next I'm going to write my inner join, and inside the inner join I'll write my subquery, which is going to be select customer ID comma, I'm going to take the minimum value from the purchased at column, which is my date column. Close this. I'll give another alias as min underscore purchased underscore at from my table name is customers. Then I'm going to group it by 1. Here 1 means the first column that you have put in the select statement, which is customer ID. So I'm grouping by customer ID. I'll close the bracket, and everything I'm going to give an alias name as t1. Now I'm going to join on t dot customer ID is equal to t1 dot customer ID, and my next condition would be t dot purchased at is equal to t1 dot min underscore purchased underscore at. I'll give a semicolon. I would request you to go through this SQL query in a detailed manner so that you understand it line by line. Let me just run it now. If I run it, okay, it has thrown me an error which says table SQL underscore IQ customer does not exist. The reason is my table name is customers. Alright, so let me run it once again. Okay, so there's one more error. It says unknown column purchases at. So we had made a spelling mistake here. It should be purchased at. Now let's try and run it. Alright, there you go. So for customer ID 101, the first purchase was made on 2nd of October 2018. Likewise, for customer ID 103, the first purchase was made on 5th of October. And similarly for customer ID 102, the first purchase was made on 5th of October again. Now moving to the 9th question. So
here we have a weather table. We want to write an SQL query to find all the date IDs with higher temperature compared to its previous dates. So if you see, we have a date ID column, we have the date and the temperature. Using this table, I want to find those IDs with higher temperature compared to its previous dates. So if you look for date ID 1, the temperature is 32. For date ID 2, the temperature is 31. For date ID 3, the temperature is 30.8. Now if you clearly notice, for date ID 4, the temperature is 31.5, which is actually higher than the previous date ID, which is 30.8. Similarly, for date ID 5, the temperature is 33, which is again higher than the previous date, which is 31.5. Now if you look at the date values, they start from 10th of March till 15th of March 2020. Now to solve this query, we are going to use SQL joins again, and I'm going to use a function called to_days. Now MySQL to_days function returns the number of days between a given date and year 0. So let's go ahead and write this SQL query. Alright, so first let me select all the rows from the temperature table which we are going to use for this particular question. I'll run it. Alright, there's some error. Actually the name of the table is weather and not temperature, so I'll write weather. Let me run it. Okay, so here you can see these are all the rows present in the weather table, and as I explained, I want to return only the date ID 4 and this date ID which is 5. Now one thing I want to make it clear here, that this date ID should actually be 6, so there was a mistake while creating the table. So please consider this date ID as 6 and not 5. So I want to return date ID 4 and date ID 5. Alright, so let me go ahead and write my SQL query. So I'll write select, I'll write a dot date underscore ID from weather as A, comma, I'll join weather as B, where A dot temperature is greater than B dot temperature, and I'll give my condition, and I'll use the function to_days and give my value a dot date underscore val is equal to, I'll use the function again to_days b dot date underscore val plus 1. Now I would like to know from our viewers, why have we used plus 1 in the where condition? So please put your comments in the chat section. Let me just run it. There you go. So here you can see my SQL query has returned the date ID 4 and 5, which means these are the date IDs where the temperature was higher compared to the previous dates. Alright. Now coming to the last question on this interesting session on SQL interview questions for data scientists. So there are two tables. One is the authors table and the other is the books table. I want to write an SQL query to find the second highest author who sold the most number of books. Now this is going to be my SQL query. Again, we are going to use joins on both tables author and books along with limit and offset operators. So let me show you how to do it. So first I'm going to join my author table and the book table. So I'll write select a dot author underscore name, comma, I'm going to find the sum of copies sold from the books table. So I am giving my alias name as b dot copies underscore sold, which is my table name. I'll give an alias as sum underscore sold, from author as A, join books as B, on I'll write B dot book underscore name is equal to A dot book underscore name. Now I'm using book underscore name as my criteria because book underscore name is the common column to both the tables. Then I'll use a group by clause. I'll write group by A dot author name. Then again I'm going to use an order by clause. I'll write order by sum underscore sold, and I'm going to order it in descending order, so I'll write DESC. I'll set my limit as 1 and offset as 1. If I run this, you will find that my SQL query has thrown an error. The reason is we have used a column called bull underscore name, so it should be book underscore name. There was an error here. Let me run it again. Okay, there was another small error. This should be sum underscore sold. Let's run it. There you go. So my SQL query has returned author 3 because author 3 sold the second highest number of books. Now let me just remove the last few lines in the script. Let me just run it now. If I run this, you can see author 1 sold the highest number of books, followed by author 3 who sold the second highest number of books, and then it was author 2 who sold the least number of books. So if I write limit 1 and offset 1, what this line of code will do is it will skip the first row and print the next row. So let's just run it, and you can see it has returned me the author who sold the second highest number of books.
If getting your learning started is half the battle, what if you could do that for free? Visit SkillUp by Simplilearn. Click on the link in the description to know more.
In today's session, we'll be discussing some of the top mathematics interview questions for data science. These questions are based on various topics in mathematics such as statistics, probability, and linear algebra. So let's begin with our first question. The first question we have is, what is normal distribution? Now, normal distribution is a probability distribution that is used to check how your data is distributed. Your data could be spread out to the left or to the right, but in many cases, the data tends to be around a central value with no bias left or right, as you can see on your screens. Now, this is called a normal distribution where half of the points are to the left and another half of the points are to the right of the center. Now, such a distribution contributes to 68% of the data falling within one standard deviation of the mean. Then we have 95% of the data falls within second standard deviation of the mean. So if you add up 13.6% and this 68% plus 13.6%, this will result to 95% of data falling within 2 standard deviations of the mean. And finally, we have close to 99.7% of the data falling within 3 standard deviations of the mean. So this is what a normal distribution is all about. Now moving on to the next question. So what are the different measures that are used to summarize a distribution? Now, to get more idea about the data and summarize a distribution, you can use 3 types of statistical measures. The first, we have central tendency measures, then we have variation measures, and finally we have shape measures. Now under central tendency measures, we have mean, median, and mode. Now the mean is the most frequently used measure of central tendency in a data set. Let me take you to the Wikipedia page and explain you what mean exactly is. Okay, so here you can see
on the Wikipedia page, it has the formula to calculate the mean of a distribution. So this is basically the summation of all the data points divided by the total number of data points. So here you can see an example. We want to find the arithmetic mean of 5 values, which are 4, 36. We'll pick the fourth element from our ordered set of points, that is 6 here, and hence 6 is the median for this ordered set of points. Now if you have an even number of observations, as you can see here, total we have 8 observations. Now the median becomes xn by 2 plus xn by 2 plus 1 divided by 2. So your median becomes the mean of the middle two numbers, that is 4 plus 5 by 2, which is 4.5. Alright. Now the next statistical measure we have under central tendency is called the mode. So the mode is the most frequently occurring value in a set of data points. So here you can see an example. We have a set of data points 6, 3, 9, 6, 6, 5, 9, 3. So your mode is going to be 6 here, since 6 is occurring thrice in the set of data points. Okay. Now under variation measures, we have variance, standard deviation, and interquartile range. So first look at what variance is. So variance is the average of the squared differences from the mean. Now this is the formula for variance. You can see xi represents the individual set of data points and mu represents the average value. So mu is nothing but the summation of all the data points divided by the total number of data points. So this is your formula for variance. Next we have standard deviation. So standard deviation is a measure of the amount of variation or dispersion of a set of values. A low standard deviation suggests that the values tend to be close to the mean, while a high standard deviation suggests that the values are very spread out. Now here you can see the formula for variance. Now this is denoted by sigma, and your standard deviation is nothing but the square root of variance. So here you can see the formula for variance. You have xi minus your mu square, which is the mean of all the data points, divided by n. Then we have the interquartile range, which is also known as IQR. So IQR is a measure of variability based on dividing a data set into quartiles. So an interquartile range measures where the bulk of values lie. So the formula for IQR is Q3, which is the third quartile, minus the first quartile. So here you can see we have a list of data points. Then we are ordering the data points first, and then we cut the list into quarters. So first you have the Q1, then you have Q2, and finally you have Q3. So for these set of data points, your IQR is going to be 7 minus 4, that is 3. Then we have shape measures. So under shape measures, we have skewness and kurtosis. So skewness is a measure of symmetry. Your distribution is symmetric if it looks the same to the left and the right of a center point. Now they are majorly of two types. One is called negative skew, or which is also known as left skew. Then we have positive skewed or right skewed. And finally we have kurtosis. So kurtosis is a measure of the tailedness of a probability distribution. It defines how heavily the tails of a distribution differ from the tails of a normal distribution. So if you consider these distributions, the kurtosis will calculate the tailedness, which is actually these areas of a distribution. Now let's look at a third question. So the question is, create a sparse matrix in Python. Now in numerical analysis, a sparse matrix or a sparse array is a matrix in which most of the elements are 0. Now there are multiple ways to create a sparse matrix. I'll show you two ways to create a sparse matrix. So let me take you to my Jupyter notebook, where I'll create a matrix first, and then we'll see how to create sparse matrix out of it. So I am on my Jupyter notebook here. First let me import the necessary libraries. So first I am going to import numpy as np, and then from scipy we'll import sparse. I'll run this cell. Okay. Next, let me go ahead and create a matrix. I'll use the np.array function, and within this function I'll create a 3 cross 3 matrix, and I'll assign the elements. So my first row will have 1 2 3. Next we'll have 4 5 6. Then we'll have 7 8 and 9. Alright, let me run this cell. Okay, now let me go ahead and print my matrix. So I'll use the print function, and let's say I'll pass in a message that is original matrix, comma, and then pass in my variable name that is matrix. Let's run it. So here you can see I have my original matrix. It is a 3 cross 3 matrix and has 9 elements in it. First, let's see how using dictionary of keys you can create a sparse matrix. So for that, I'll write the print statement, and then I'm going to use a function which is called DOK, that stands for dictionary of keys underscore matrix, and I'll pass in my variable name which is my original matrix. So if I run this, you can see I have got my dictionary of keys sparse matrix. Next, I'll show you how using diagonal storage paste you can create a sparse. That I'm going to use another function that is sparse.dia, which stands for diagonal underscore matrix, and within this function I'll pass in my original matrix variable name. If I run this, you can see we have created diagonal storage based sparse matrix. Alright, now moving to the next question. So given below is a matrix. Now we need to find the inverse of this matrix. Now the inverse of a square matrix A, which is sometimes called as a reciprocal matrix, is a matrix A inverse such that the dot product of A and A inverse is always I, which is an identity matrix. Now in NumPy we have a function which you can see here, that is np.linalg.inv, that helps you find the inverse of a matrix. Let me show you on the Jupyter notebook. First, let me print my original matrix. Alright, now here I'll use the function with min, that is np.linalg.inv, which stands for inverse, and then pass in my variable name, that is matrix. If I run this, you can see I've got the inverse of my original matrix. Now moving to our fifth question. So this question is related to probability. You call 2 Uber X and 3 lifts. If the time that each takes to reach you is IID, what is the probability that all the lifts arrive first? Next, we want to find what is the probability that all the Uber X arrive first. Now this is fairly a simple question. First, let's look at all the lifts arrive first. Then first we need to find the probability that the first car is a lift, which is going to be 3 by 5, since we have 3 lifts and total we have 5 vehicles. Next, we want to find the probability that the second car is a lift, which is going to be 2 by 4. Third, we need to find the probability that the third car is also a lift, which is 1 by 3. Now, arrive first is going to be the multiplication of the product of the above 3 probabilities, that is 3 by 5 into 2 by 4 into 1 by 3, which is nothing but 1 by 10. Next, let's say you want to find for all the Ubers that arrive first. So you need to find the probability that the first car is Uber, which is nothing but 2 by 5, since we have 2 Ubers. Next, the probability that the second car is an Uber is going to be 1 by 4. So the total probability that all the Ubers arrive first is going to be the product of 2 by 5 and 1 by 4, which is also 1 by 10. Now moving to the sixth question, the mean, median and mode of a distribution are 30, 25 and 20. We need to determine if the distribution plot will be positively skewed or negatively skewed. So you can see from the distribution graph, the mean is to the right, median to the middle and mode to the left. So since the value of mode is less than the mean and median, the data will be positively skewed. And similarly, the skewness of the distribution is on the left if the mean value is less than the median and the mode occurs at the highest frequency of the distribution. Now the next question we have is, what are covariance and correlation? So covariance and correlation are measures that help you understand the relationship between two continuous variables. So covariance tells the direction of the linear relationship between two random variables. The direction means if the variables are directly proportional or inversely proportional to each other. So increasing the value of one variable might have a positive or a negative impact on the value of the other variable. Now covariance can take any value between minus infinity and plus infinity. So below you can see the formula to calculate the covariance. So you have summation xi minus x bar or x dash here represents the mean, xi represents the individual points, then this is multiplied by yi minus y dash or the mean of y divided by the total number of observations. Next we have correlation. So correlation explains the change in one variable leads to how much proportion changes in the second variable. Correlation tells how strongly two random variables are related to each other. It takes values between -1 and +1. A negative correlation means they are inversely proportional to each other. A positive correlation means they are directly proportional to each other. If the correlation coefficient is 0, then there is no linear relationship between the variables. So here below you can see the formula to calculate the correlation. Now moving to the eighth question. So what are the sampling methods used in data science? Now sampling is a statistical technique that is used to select, manipulate and analyze a subset of data points and find patterns and trends in the large data set being examined. Now there are two types of sampling methods. We have probability sampling and non-probability sampling. Now under probability sampling we have something called as random sampling. So in random sampling, every individual is chosen entirely by chance and each member of the population has an equal chance of being selected. Then we have stratified sampling. So in stratified sampling, subsets of the population are created based on a common factor and samples are randomly collected from each other. Now talking about systematic sampling. So in systematic sampling, a sample is created by setting an interval at which to extract data from the larger population. An example could be selecting every fifth row in a spreadsheet of 100 items and creating a sample size of 20 rows for analysis. And finally, under probability sampling we have cluster sampling. So in a cluster sampling, subgroups of the population are used as the sampling unit rather than individuals. So the population is divided into clusters and a whole cluster is randomly selected to be included in the analysis. Now let's look at the sampling methods that are present under non-probability sampling. So first we have convenience sampling. So for convenience sampling, the samples are selected based on the availability. So this method is used when the availability of samples is rare and costly. So based on convenience, samples are selected. Second, we have quota sampling. So quota sampling depends on some preset standard. The proportion of characteristics in sample should be the same as the population. Next, we have purposive sampling. It is also known as judgmental sampling. You select members of sampling on the basis of the objective of the study. It is very useful when you want to reach a particular or targeted sample quickly. Finally, we have snowball sampling. So the snowball sampling technique is used in situations where the population is completely unknown and rare.
Now coming to the 9th question in our list. So explain what p-value tells about statistical significance. So p-value is a statistical test that is used in hypothesis testing. It helps you to decide whether to accept or reject the null hypothesis. The null hypothesis, represented as H0, is a commonly accepted fact. It is the opposite of alternative hypothesis. Researchers and scientists work to reject or disapprove the null hypothesis. They come up with an alternative hypothesis that they think explains a phenomenon, and they work to reject the null hypothesis. For example, null hypothesis or H0 could be the world is flat, and an alternative hypothesis could be the world is round. So lower the p-value, the greater the statistical significance of the observed difference. Now the p-value is just one piece of information you can use when deciding if your null hypothesis is true or not. The p-value lies between 0 and 1, as you can see here. The threshold for p is set to 0.05. When the value is below 0.05, the null hypothesis is rejected. Now coming to the final question in our list of mathematics interview questions for data science. So the question is, what do you understand by type 1 versus type 2 error? Now in statistical theory, the statistical error is an integral part of hypothesis testing. In statistical hypothesis testing, no test is ever 100% certain. That's because we rely on probabilities to experiment. Even though hypothesis tests are meant to be reliable, there are two types. So type 1 error occurs when the null hypothesis is true and we reject it. It is also known as a false positive finding or conclusion. An example could be an innocent person is convicted. And type 2 error occurs when the null hypothesis is false and we accept it. It is also known as false negative finding or conclusion. An example could be a guilty person is not convicted. So here you can see we have a reality where your null hypothesis is true, and here we have the null hypothesis is false, and this is where the type 1 error lies. So this can also be represented as false positive, where the null hypothesis is true and we reject it, and this could be false negative, where the null hypothesis is in reality it's false and we accept it. In our previous video, we had discussed the important interview questions on mathematics, statistics, probability and linear algebra that are often asked in any data science interview. Today, we will learn about some of the machine learning and deep learning interview questions. So let's begin with our first question. The first question is, how to detect outliers in data? So in data analytics and machine learning, you often find data points that lie at an abnormal distance from other points in a random sample from a population. Those are called outliers. Now outliers in data can significantly impact any prediction analysis. There are majorly three different methods to treat outliers. First, we have the univariate method. It is one of the simplest methods for detecting outliers. The univariate method uses box plots. A box plot is a graphical display for describing the distributions of the data. Box plots use the median and the lower and upper quartiles. This method looks for data points with extreme values on one variable. Next, we have the multivariate method. So the multivariate outliers can be found in an n-dimensional space having n features. We look for unusual combinations of all the variables in this method. Finally, we have Minkowski error. This method reduces the contribution of potential outliers in the training process. The Minkowski error is a loss index that is more insensitive to outliers than the standard mean squared error. Now moving on to the second question, what is a confusion matrix? So a confusion matrix is a table that is used to describe the performance of a classification model on a set of test data for which the true values are already known. The target variable has two values, positive or negative. The columns represent the actual values of the target variable, which you can see here. The rows represent the predicted values of the target variable, which you can see here. Now there are four important terms that are related to confusion matrix. First, we have true positive, which is this one. So in true positive, the predicted value matches the actual value. So the actual value was positive and the model also predicted a positive value. Then we have true negative, which is also represented as Tn. The true negative depicts the predicted value matches the actual value. Now the actual value was negative and the model predicted a negative value. Next we have false positive. Now false positive is also known as type 1 error. In false positive, the predicted value was falsely predicted. The actual value was negative, but the model predicted a positive value. And finally, we have false negative. Now false negative is also known as type 2 error. So in false negative, the predicted value was falsely predicted. The actual value was positive, but the model predicted a negative value. Now moving to our third question, which is explain the ROC curve. Now the ROC curve is one of the most important evaluation metrics for checking the performance of any classification model. ROC stands for Receiver Operating Characteristic. Receiver Operating Characteristic or ROC curve is a method to compare the diagnostic tests. The ROC curve is created by plotting the true positive rate against the false positive rate at various threshold settings. So here on the y-axis you have the true positive rate, on the x-axis we have the false positive rate. The true positive rate indicates the proportion of observations that were correctly predicted to be positive out of all positive observations. Similarly, the false positive rate is the proportion of observations that are incorrectly predicted to be positive out of all negative observations. You can take an example. Suppose in medical testing, the true positive rate is the rate in which people are correctly identified to test positive for the disease in question, let's say the coronavirus testing. ROC does not depend on any class distribution. This makes it useful for evaluating classifiers predicting rare events such as diseases or disasters. Now moving to the fourth question, we have what are the assumptions for linear regression? So linear regression analysis is used for modeling the relationship between a single dependent variable y and one or more feature or predictor variables. Some of the important assumptions for linear regression are, so first, they should have linearity. So linear regression needs the relationship between the independent and the dependent variables to be linear. It is also crucial to check for outliers since linear regression is sensitive to outlier effects. Next we have homoscedasticity. Homoscedasticity illustrates a situation in which the error term, that is, the noise or random disturbance in the relationship between the features and the target variable, is the same across all levels of the dependent variables. Third, we have independence. So observations should be independent of each other. Finally, we have no multi-collinearity. So there should be little or no multi-collinearity. Independent variables should not be too highly correlated. Now moving to our fifth question in our list of interview questions. The question is, what is regularization in machine learning? Explain the L2 regularization. So regularization is a machine learning technique that is used to reduce the errors by fitting the function appropriately on the training set in order to avoid overfitting of data. So overfitting happens when a model learns the detail and noise in the training data to the extent that it negatively impacts the performance of the model on new data. So here you can see we have a nice plot which shows how overfitting of data can be visualized. And here we have a good fit line over the same data points. So this is also known as the regression line. Now L2 regularization is also known as ridge regression. So ridge regression modifies the overfitted model by adding the squared magnitude of coefficient as a penalty term to the loss function. So on the right you can see a set of data points plotted, and we have our linear regression line, and here we are calculating the cost function for the ridge regression line. So our cost function is actually loss plus lambda into summation of w squared, where loss is actually the sum of squared errors or squared residuals. Lambda stands for penalty for the errors. W is called the slope of the curve or line. Okay, now consider a case where there are 2 points passing through the linear regression line. Now if you calculate the cost function, we get the value as 1.69. So here we have assumed that loss is 0 since the 2 points lie directly on the line. We have taken lambda to be 1 and w is 1.3. So if you use this function or this formula, you get the cost function as 1.69. Now moving ahead, let's consider another situation where we'll calculate the same cost function for the ridge regression line. There is some loss for both the points as they are not on the same line. So here you can see the sum of squared residuals is 0.05, is actually is the sum of 0.2 square. I'm assuming this as 0.2 and 0.1 for this one. So if you square both and add it, the value is 0.05. A lambda is again 1 and w we have assumed to be 0.6. Now if you find the cost function, the value is 0.41. Let's draw the linear regression line and the ridge regression line with all the points. We find that the ridge regression line as the best fit since its cost function is less.
If getting your learning started is half the battle, what if you could do that for free? Visit SkillUp by Simplilearn. Click on the link in the description to know more.
Now coming to the sixth question. What are the different methods to split a tree in a decision tree algorithm? So there are three methods to split a decision tree. First we have variance. So reduction in variance is an algorithm that is used for continuous target variables. This algorithm uses the standard formula of variance to choose the best split. So here you can see the standard formula of variance, which is summation of x, that is all the individual points, minus x bar, which is the mean, squared divided by the total number of observations. Now the split with lower variance is selected as the criteria to split the population. Now the steps to calculate variance is, you need to calculate variance for each node, and then you need to calculate for each split as the weighted average of each node variance. Moving ahead, the second method we have is information gain. So information gain is used for splitting the nodes when the target variable is categorical. It works on the concept of entropy. Now the degree of disorganization in a system is known as entropy. So here you can see the formula for information gain, which is 1 minus entropy. Finally we have Gini impurity. So Gini impurity is the probability of incorrectly classifying a randomly chosen element in the dataset if it were randomly labeled according to the class distribution in the dataset. So below you can see the formula for Gini impurity. So we have 1 minus summation of pi whole square, where n represents the number of classes and p of I represents the probability of randomly picking an element of class I. Now moving to the seventh question. So the question is, how do we find the optimum cluster value in Kmeans clustering algorithm? Now there are two methods to find the optimum cluster value. So first we have the elbow method, which is one of the most well known for finding the optimum number of clusters. So in this method you need to calculate the within cluster sum of squared errors for different values of k and choose the k for which within cluster sum of squared errors first starts to diminish. So in the below plot of squared errors versus the number of clusters k, you can see at k is equal to 4 the squared error starts to diminish. So hence our optimum k value is 4. Next we have the silhouette method. So the silhouette method measures how similar a point is to its own cluster compared to other clusters. The average silhouette method computes the average silhouette of observations for different values of k. The optimum number of clusters k is the one that maximizes the average silhouette over a range of possible values for k. The silhouette score reaches its global maximum at the optimal k. So in our case, the average silhouette reaches maximum at k is equal to 2, which you can see here. So our optimum cluster value will be 2 here. Moving ahead, the eighth question in our list is, how does the pooling layer work in a convolutional neural network? So the pooling layer performs a downsampling operation in order to reduce the dimensionality of the feature map. So in the pooling operation, you slide a two-dimensional filter over each channel of feature map and summarize the features lying within the region covered by the filter. It is a common practice to periodically insert a pooling layer in between successive convolutional layers in a convolutional neural network architecture. So the pooling layer operates independently on every depth slice in the input and resizes it spatially using the max operation. So in the diagram shown here, you can see we have a rectified feature map. We are using a 2x2 filter and performing a max pooling operation. So consider this as the filter. If you perform the max operation over the values, let's say 0, 5, 3 and 1. So considering this one, our pooled feature map maximum value will be 5. Similarly, for this chunk of data, it is going to be 7. Next, if you slide the filter over this square frame, you get 8, and similarly here you get 6. So this is also known as a pooled feature map. Moving ahead, the 9th question in our list is, how does LSTM network work? So long short-term memory networks are a type of recurrent neural networks that are capable of learning order dependence in sequence prediction problems. So remembering information for long periods of time is practically their default behavior. Now LSTMs also have this chain-like structure which you can see here, but the repeating module has a different structure. So instead of having a single neural network layer, there are 4 interacting in a very special way. Now you can see these are called as gates. These gates contain sigmoid activations. A sigmoid activation is similar to the tanh activation. Instead of squishing values between -1 and +1, it squishes values between 0 and 1. An LSTM has 4 gates. Now these are called forget, remember, learn and use or output. So if you see this, in the first step, we use the forget gate that decides what information should be thrown away or kept. The information from the previous hidden state and the information from the current input is passed through the sigmoid function. Values come out between 0 and 1. So if the value is closer to 0, it means you need to forget that information, and if the value is closer to 1, it means you need to keep that information. Next, we have the input gate. So the input gate is used to update the cell state. First, we pass the previous hidden state and the current input into a sigmoid function. That decides which values will be updated by transforming the values to be between 0 and 1. 0 means not important and 1 means important. You also pass the hidden state and current input into the tanh function to flatten the values between -1 and +1. This helps to regulate the network. Then you multiply the tanh output with the sigmoid output. The sigmoid output will decide which information is important to keep from the tanh output. And finally, in step 3, we have the output gate. This output gate is used to decide what the next hidden state should be. First, we pass the previous hidden state and the current input into a sigmoid function. Then we pass the newly modified cell state into the tanh function. We then multiply the tanh output with the sigmoid output to decide what information the hidden state should carry. The output is the hidden state. The new cell state and the new hidden state is then carried over to the next time step. Finally, talking about the last question in our list of interview questions, we have explain the concept of gradient descent in deep learning. Now gradient descent is an optimization algorithm which is mainly used to find the minimum of a function. In machine learning, gradient descent is used to update the parameters in a model. Parameters can vary according to the algorithm, such as coefficients in linear regression and weights in neural networks. You can see we have these maps, and on the y-axis we have the loss, on the x-axis we have the weight, and here we are trying to find the local minimum or the global minimum. Now this gradient descent method is used to minimize the cost function and update the parameters of the learning model. The gradient always points in the direction of the steepest increase in the loss function. The gradient descent algorithm takes a step in the direction of the negative gradient in order to reduce the loss as quickly as possible. To determine the next point along the loss function curve, the gradient descent algorithm adds some fraction of the gradient's magnitude to the starting point. Now this process is repeated to find the global minimum. Alright, with that we have reached the end of day 7 of our data science week. I hope the past 7 days were really interesting and informative that helped you learn the leading data science skills. If you have any queries, please feel free to put them in the comment section of the video. We'll be happy to help you. Thank you all for watching this live session. Thanks again and keep learning.